Yeah, let's finish writing quickly so that we can start. Yeah, can we start? Are we sure? Ready? All right, like that's the spirit. Now from here, now you might already think that I am supposed to just divide everything by y and continue. But sorry to burst your bubbles, this is not following the normal order of a Bernoulli. Because in a normal order of a Bernoulli, I must have what? P of x here. But what happened here? I don't have any x that is existing here. So I have to make sure that the x that is not there comes back. So how do we do that? So I can say that I'll divide everything in by what? By xy. Divide through by what? Xy. And what do I have here? I have xy. No, it shouldn't be xy. It should be what? 1 over y dy dx plus what? This will give me what? This will give me what? 1 over x ln y. Are we together? Then equals to what? Exponential what? Exponential x. Yes or no? So from here, what do I have? I can have this one to be y raised by minus 1 dy dx plus what? 1 over x ln y equals to what? Exponential x. So what's your z here? Your z is what? Ln y. Then the z, the x here is going to give me what? 1 over what? Y dy dx, which is exactly the same thing as what is here. I mean now. So from here I can call that one what? The z dx plus what? 1 over x z equals to what? Exponential x. And from here, what's your p of x? Your p of x is 1 over x. Your q of x is equals to what? Exponential x. And from here, your integrating factor is equals to what? Sorry, not integral now. It should be exponential integral 1 over what? X dx, which will give me what? X as my final answer. Yes or no? Then from here, multiply everything here by what? By x. So you can have the z dx plus 1 over x z multiplied by x equals to what? X exponential what? X. Yes or no? Now for me to differentiate this, I have x dz dx plus what? Z equals to what? X exponential x. Then everything here automatically becomes, okay, don't let me tell what it automatically becomes. So everything here automatically becomes what? D dx of z dot x equals to, what do I have here? X exponential what? X. Then I can have here d open bracket z plus x equals to what? S exponential x dx. Then I can now do what? Integrate both sides. Are we together? Then if I integrate both sides, what do I have? Integral d z multiplied by x equals to integral x exponential x dx. Then so from here, what do I have? Zx equals to, how do I integrate this one? How do I integrate this one? How do I integrate that one? By what? By parts. Good. So I can say that here your u is what? X. Your dv is equals to what? Exponential x dx. Then du is equals to what? Dx. And v is equals to what? Exponential x. And what is integration by part? Integral u dv equals to uv minus integral what? V du. So substituting that in, so I have, what is my u? X exponential x minus integral exponential x dx. Your final answer here is what? X exponential x minus what? Exponential x plus what? Plus c. Don't forget that everything is equals to what? Zx. And for me, divide everything by x, so I have z is equals to what? So exponential x minus exponential x over x plus what? C over x. Don't forget, what is your z here? Your z was what? Ln y, which is equals to what? Exponential x minus exponential x over x plus what? C over x. And that's my final answer. It's not long now. Is it long? It's not long now. All right, so continue on one more. Continue on one more. One more. One more. One more. Thank you. So by God's grace, I will not teach you that exact that I've been saying since morning. I want to teach you, exact. Okay, you said one more. Let me make it a little bit more interesting. Okay, let's do it in this way. Okay, I love this. Okay, I love this. This is fantastic. I love it. Yes, I love it. So let's look at it. Sec x tan x tan y minus exponential x, everything dx plus sec x sec square y dy equals to 0. Is it your love? All right, so let's start. How does it look like? It looks interesting now. Yes, I love you. So now from here, let's look at it together. So you might just look as if it's just complex. It's just normal small stuff. You guys always fear small thing. Same way, no fit talk. So now let's start in this way. Now first of all, let's try to create my dy dx first. That's the most important thing. Then that means I have to take everything into the other side. What do I have here? I have sec x sec squared y dy is equals to minus sec x tan y. Are we together? Tan y, what is that? Minus exponential x dx. Then from here, what do I have? I'll have sec x sec squared y dy equals to exponential x. Are we together? Minus what? Sec x tan y. Everything here is what? Dx. Then if I divide by dx, what do I have here? I have sec x sec squared y dy over what? Dx. Are we together? Is equals to what? Exponential x minus what? Sec x tan y. Are we together? Let me bring this one here to the other side. I have sec x sec squared y dy dx plus what? Sec x tan y equals to what? Exponential what? X. Are we together? So divide everything by exponential x. So if I divide everything by exponential, no, not exponential x, by sec x, then I can have what? Sec squared y dy dx plus what? Tan y. Are we together? Which is equals to what? exponential x cos x. Yes or no? Yes or no? Everybody in Jora, but difference. Now, so from here, I hope you know that here I can say that my y, or not y now, z is equals to what? Tan y. Abi now? And the z dx is equals to what? Sec squared y dy dx. Yes or no? Yes or no? Yes or no? Which is exactly equal to what I have here. So everything here can now be written as what? Dz dx plus tan x z equals to what? Exponential x cos what? Cos x. Then here, p of x equals to what? P of x equals to tan x. Yes or no? Yes or no? Yes or no? Until to give up. Don't give up. Now we have p of x equals to what? Tan x, and also that q of x here is equals to what? Exponential x, which is what? Cos x. Yes or no? Then now for me, what do I have here? I have that my integrating factor. Can you just tell me with, okay, let's attention to quick. I don't want to write exponential. What's my integrating factor? Straight up. 1 over cos x. And now, do you know why? Because if you integrate tan x, you have what? Minus ln cos x. And that minus will go back to cos x. And exponential will cancel ln to give you what? 1 over what? Cos x. Abi now, I just smart to now. Abba. Abba. Then so from here, I can now move on. So from here, then from here, I've got my integrating factor. So what am I multiplying? I'm multiplying everything here by my what? By my integrating factor. So I can have dz dx multiplying. No. Dz dx plus z tan x. Are we together? Z tan x multiplying by what? 1 over what? Cos x. Are we together? Equals to exponential x cos x multiplied by what? 1 over what? Cos x. You have seen that what seems as if it's scary is not scary. And for me, you have what? The z dx multiplied by 1 over what? Cos x plus z tan x. I hope you know that 1 over cos x is as what? Sec x equals to what? Exponential x. Yes or no? And everything becomes automatically d dx of what? Z multiplied by what? Sec x. Yes or no? Then your answer here is what? Exponential x. Then you have d open bracket z sec x equals to what? Exponential x dx. And if you integrate both sides, by integrating both sides here, so by integrating both sides, what do you have? You have integral d z sec x equals to what? Integral of what? Exponential x dx. Are we together? Then so from here, what do I have? I can now have this one to be what? D. No, it won't be d. It will be what? Z sec x equals to what? Exponential x plus c. Then divide everything by sec x. What do I have? I have z is equals to exponential x cos x plus c cos x. And what's your z here, please? Z is tan y. The answer is what? Tan y. Exponential x cos x plus c cos x. And that's the final answer. So, to the DD, got more info. So let's go and look at what? Exact differential equation. It's the simplest. The simplest. Exact differential equation. So this will happen. Listen, I will continue the class till when this fine boy here becomes 25. But this is what will happen. I will end the section now. But the next section, which is still the same thing as this section, so that means I'm still continuing. So that one will just be more of questions. So we'll just solve questions for 2 hours. And you can look at them. So if you know you are interested in staying to those solve questions, you can sit. Whatever I'm just doing here, I'm just doing as an example so that the format can stick to our head. You understand what I'm trying to say like that? So it's a free choice. Do you get that? I wish you. Now, exact. Can we start? Okay, I'm waiting. If you want to leave, you can. But I said I'll just continue. I'll just go back and we'll solve more questions. More questions. I think in 2 hours we should be able to solve probably 30, 40 questions on differential equations, starting from homogeneous to exact. Yeah. And after that one, I will now know that any question you see on first order differential equation, if there's nothing else that is happening, again you won't try to win. So you can feel free to wait and you can feel free to go. As I was saying, I am here for you. As long as I what? Are here for me. And you do. Right fast. So your section is ending by 23 here. That's about 32 minutes from now. Most of you, it's not as if you have something to go and do at home. I'm going to go home and go and be sleeping. Now, I'll still continue this section till this thing becomes 25. After 25, you do what comes next. I don't know. Now, exact. Can we start? Can we start? Exact. Exact. Can we start? Exact. Can we start? All right, let's start. Exact. Yeah, this is my best. Why you always? Okay, before I start, can we recollect partial differential equation? Partial derivative. 2m test 2 1. We and let me tell you more. Don't you go more? You know, because I just thought you of recent. So now, how do we recognize exact differential equations? So let's start. So we have 30 minutes to trash that. Ready? Okay, good. How do you know exact differential equation? They're always written in this format. M dx plus n dy equals to what? 0. That's how all exact are always written. This is the format. So anything about theory in this case is always the format. But there are some cases that you might want to, for example now, I can call everything here m dx, and you get what I'm trying to say like that. And another thing again, if they will ask you to solve exact, they will like specify that you use what? Exact. Do you know why? Because if they don't specify, do you know that this one too is also in this format? Abi now? So that's why they have to specify. You get what I'm trying to say like that? Now MDX, so now to test for exactness, so to test for exactness, partial m partial y must equal to partial n partial x. That's the test for what? Exactness. And we'll now move on to the methods, the ways we can solve it. So methods of solving. Method of solving. Now the first one is step 1. Integrate m with respect to x, keeping y constant. Number 2, integrate with respect to n respect to x all times without x. Answer 1 plus answer 2 equals to constant. So that's everything on exact. And probably next class, if we meet, then probably before we look into second order differential equations, then I can briefly talk about inexact. I'll get someone trying to like that. I can briefly talk about inexact. All right, so this is everything. Yes? No, that is for the same. All of these methods is what you must use if you want to use exact. All. So let's talk about examples. So if you look at the examples, all right, are you ready? All right, let's solve. Now, solving this. So first thing, let's pick the label according to what we have there. The first thing, so if I look at it very well, I can say that my m is equals to what? 5x to the power of 4 plus 3x squared y squared minus what? 2x y cubed. And my n is equals to what? 2x cubed y minus 3x squared y squared minus what? 5 to the power of 4. Now, first of all, before you can solve, you have to first of all test. Yes? Boy, sit down. I understand your question. Like, sit down and talk. You make it look like Yes, they will specify if you have to use exact. Use any other method, yes. But they will specify. And another thing to be on the safer side, whenever you have something written like this, first of all, test for exactness. That's what I want to do now. And if it had tested for exactness and it was exact, then I will have used exact straight up to solve it. But look at it from that one can never be exact. I know that one cannot be exact. There's no need for you to test for what cannot be exact. You understand? But the normal norms, they will specify. But if peradventure you see something like that, test for what? Exactness. Now let's test for the exactness of this. So what does this? Now let's now look for partial m, partial y. What does this thing mean? It means that you want to differentiate only x. Anything apart from x is what? The constant. Yeah? Yes, that's it now. Partial m, partial y. I'm testing for exactness. I'm following that method. So what does this one mean? It means that you are only differentiating anything that is what? That is y. Any other thing apart from y is what? Constant. So I can differentiate this one here. I can differentiate this. So this one will give me what? 6x squared y minus what will this one give me? 6xy squared. Yes or no? Then partial n, partial x. Differentiating how many? Only what? Only x here. What do I have? 6x squared y minus what do I have here? 6xy squared. And find out that both of them are the same thing. So since both of them are the same thing, that means this differential equation is what? Is exact. Do you understand? Okay, good. Now let's start solving. Number 1. What they ask you to do? Integrate m with respect to what? X. Abi now? Keeping y as constant. Abi now? Now what does that mean? It means that you will integrate 5x to the power of 4 plus 3x squared y squared minus 2x y cubed dx. So that means that even y here will be treated as a constant. So if I integrate this one, what do I have? 5x5 over 5 plus clearly my formula 3x cubed over 3y squared. Are you seeing it like that? Minus 2x squared over 2y cubed. That y, nothing will touch the y. You treat the y like the way you treat any number. And from here, if you reduce this, so your answer 1 is equals to what? X to the power of 5 plus x cubed y squared minus what? X squared y cubed. Are we together? Now, number 2, integrate n with respect to what? Y. But this time around, the only thing you want to integrate in n is all terms. Any term that does not have x is what I want to integrate in n. Which term in n does not have x? Minus this. So that's the only one I will integrate. Minus 5 raised to the power of 4 dy. And at the end of everything, this will give me what? Minus 5 y raised to the power of 5 over 5. Are we together? Then everything should give me what? Minus y5. Then number 3 is now telling me that the answer is what? Answer 1 plus answer 2 equals to what? Constant. So what is answer 1? Answer 1 is x to the power of 5 plus x cubed y squared minus x squared y cubed plus what is answer 2? Minus y raised to the power of 5 equals to what? C. Open this bracket and you have what? X cubed plus x cubed y squared minus x squared y cubed minus what? Y raised to the power of 5 equals to C. And that's my final answer. I'm waiting for us to finish writing. Yes. Yes. You know one thing about you guys that always piss me off? If something is too simple, there's always something in your mind that always tell you that the thing is wrong. Why? This is because that everything I did is not even up to one board compared to everything I've been doing. Just to solve one question. Fine, boy, this is the end now. Okay, this is not the end. For us to make this the end, make y the result of the formula there. But literally, this is the end. You don't have to do anything again to it. This is the end. That's why I said that exact is very, very simple. As long as you can what? Remember those principles that are there. And I said, you can wait and we will practice more and more and more and more questions. You don't have to wait. Yes, we can make it exact. That would be when we are dealing with inexact. But we have not entered that one yet. Let's look at when it is exact first. All right. Ready? Another one. Maybe it is with us now. It's simple now. You play my phone. Okay. Now let's look at this one too again. So what do I have here? I have y squared exponential x y squared plus 4x cubed dx plus 2xy exponential xy squared minus 3y squared dy equals to what? 0. So from here, ready? 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 Okay. So what's your m here? Your m here is equals to what? Y squared exponential x y squared plus what? 4x cubed. And your n here is equals to what? 2xy exponential x y squared minus 3y squared. Altogether. Then from here, let's test. Partial m, partial y. Have you know? So now, do you know that this one here, I can't just integrate it and differentiate it normally? Because this one, I have a y here and I have another y. I have to do it what? Use product through. So now, let's use product through. This is u, this is what? This is v. You're supposed to do that by now. Then what is your u here? Y squared. So if I differentiate this one with respect to y, what do I have here? I have 2xy exponential what? Xy squared. Then plus, I have exponential xy squared. If I differentiate y squared, what do I have here? 2y. Then, I think I can differentiate this also. Also, if I want to differentiate partial n, partial x. So I need product through here, which is 2xy. If I differentiate this one with respect to x, what do I have here? Y squared exponential xy squared. Then plus exponential xy squared. If I differentiate it on respect to x, I have what? 2y. That's normal differentiation. Then partial m, partial y. If we open this bracket, what do I have? 2xy cubed exponential xy squared plus 2y exponential xy squared. And this one here is what? Partial n, partial 2xy cubed exponential xy squared plus what? 2y exponential xy squared, which is the same thing. And since both of them is the same thing, so I can say that it's exact, yes or no? And so it's due to the fact that it is exact. So let's start. So answer number 1. So number 1, what do I have to do? Integrate m. Okay. I told you that this one here is, I'm using product through. Write this one out. Differentiate this one here with respect to y. The only thing you'll be differentiating will be what? Y squared. X is a constant, so that will give you what? 2xy. Then write your question back here. That's the trick for explanation now. then plus, then continue with this. What happened with the n? This is u, this is what? V. Write u. If I differentiate this one here, what will I differentiate? Y squared, which will come down, and write your question back again. X now, and now those are the same thing. If you are dealing with respect to x, does that mean that 2x squared here will give you 2x? But if you differentiate it, so that means you still take cognizance to the what? To the constants that is there. Do you understand? If you say everything here was y squared, then I would not even bother to even differentiate it. But here it has what? X and y squared together. Just like, and I told you that here, the y there is a what? Is a constant. That's how you have that. You get? Just like the same way if you differentiate 5x squared, and you have what? 10x. How do you get 10x? You write your 5 multiplied by what? Your 2x. Your constant first, then you differentiate that function next. So you go and trying to say like that. This one here, what is the constant here first? Y squared. If you differentiate x here, what do I have here? 1. Then exponential trick is what? Write your question back. Then you can follow suit with everything again. It's as simple as that. And you can slow down. You slow down. Ask question if you want to ask or explain. Ask now. No one's asking question. Okay. Yes, sir. Two x y u exponential x y squared v. U the v. Write this one. 2xy. I want to differentiate this one. I have xy squared as a constant. Yes. Who asked what department are you? Who said it? I'm waiting for you guys. No. I only minus from 1 if what I'm differentiating is x. This one is not x now, it's exponential. What's in here? Okay, good. Nice. After pause, I'm waiting for you guys. Let's continue, please. I should continue. Thank you very much. So, number 1, which is you want to integrate m d what? M dx. Yes or no? No. Yes, you are integrating m with respect to what? X. So what would that be? I want to integrate everything with respect to x here. So what would I have? Y squared exponential x y squared plus what? 4x cubed. The what? X. Don't forget that here y is a what? Constant. Just close everything and just imagine as if you want to only integrate exponential x. And if you integrate exponential x, what will you have? You have exponential x. So the answer to this one will now give us what? Y squared exponential x y squared plus, if I integrate this one, what do I have? 4x4 over what? 4. And the same thing here is what? Y squared exponential x y squared plus what? Plus x to the power 4. That's answer 1. Now answer 2 is what? Integrate what? N with respect to what? Y. All terms that does not have x. Which one does not have x here? This is the one that does not have x. So minus 3y squared dy, which will give me what? Minus 3y cubed over 3, which is what? Minus y cubed. Are we together? Are we together? Then from here, your number 3 is now saying that answer 1 plus answer 2 equals to what? Constant. So what is your answer 1 here? Answer 1 is what? Y squared exponential x y squared plus what? X to the power of 4 minus what? Y cubed is equals to what? C. And that's the final answer I have there. Ma? No, you add x to it now. Those are the same way if you integrate 2, you get 2x. So as I've said, I'll still continue the class, but 205 will be welcome because basically 205 and 315 is the same thing for now. So I welcome 205 people, but this is what will happen. Immediately as it is 23 there, then I'll just switch to question modes. We'll be solving questions on all the type of methods we have till we finish. I think that's okay by that now. Abi now? So 3152 people can wait. We can solve as many questions as we can solve. Are we together? So I welcome 205. If you're around, you can start coming to the front. You get that? But don't know that if you're about to leave, it's still the same thing. So I don't expect that there will be anyone that will leave. I don't expect. Now, since I'm still doing the same thing, it's not actually as if I never show up to now. So, as we've said, so if we are done with this, still the same differential equations. Still the same differential equation. But this is where we now start from. We start our question back again from what? From separation of variables. Then we take homogeneous questions, we take linear questions, and we take what? Yes, I will specify it. It means I want to give the question. So as we are writing it, we are solving it together. The goal is that at the end of everything, we should be able to what? Solve any differential equations that we can see. That's the goal. Do you understand what I'm trying to say like that? So 205 people, you are welcome to enter. Wait, at least calm down. Eh? Sit down. I'm not done. You can only leave when this thing, let me tell you, you can only leave when this thing becomes 23. So as I've said earlier on, so that will be that. So let's just quickly. So the next class will be meeting. When is the next class again? You know that. Check the timetable yourself. So the next class will be meeting. This is what will happen. Let's sketch the map. Let's sketch the map. The next time we'll be meeting. I said it. 205 is welcome to enter. 205 and 315 have the same syllabus. So I'm still continuing with the same flow that I'm flowing with. So you are welcome to enter. So as I was saying, so the next class we meet for 205 or 315 by God's grace after this class will be that we are entering straight up what? Second order differential equations. Inside that second order differential equations, we'll now be looking at variation of parameter. I will intentionally go and learn that course because of you guys. Because last year past question, for every question that they had, there was at least one question of what? Variation of parameter in it. Yes, for 315 particularly. So, in my own time then it was long, so I intentionally skipped it. I skipped the learning in my own time. But for you guys, because I want to teach, I'll go and learn it. I'll come and teach you next time we have it. Yeah, this period, yeah. It will be this period. So now, yes, it will. Yes. So as I've said, so let's sketch our map. So next time we'll be meeting for both 315 and 205. Next time we'll be meeting will be that we'll be discussing what? Fine boy, sit down. I'm not done. Abba. We'll be talking about second order differential equations. Then we'll look at method of undetermined coefficient first. I trust God that probably the next time we meet, we might be able to finish it. We might. And after we are done with second order differential equations, then we can now strictly enter Laplace. Look at Laplace straight on, face to face. Your topic for test and exam will start from Laplace. We'll stop at Laplace for test, even for 315. 315 and 209, they are like this. Like it's the same content, but just in different level. It is the engineering it is the mathematics you're supposed to do in 200 level that it just shifts for you to 300 level. It's still the same content. There's no difference. It's towards the ending of the course that they just add a little spice to it. Now, the reason why they make it different is because that is not done now. Because they believe that if they make it equal, then they are part of some test question that 205 will do, that they will beat in 315. So if you want to study, I would advise any 205 or 315 student that study 205 past question and study what 315 past questions. It's the same thing, no difference. Personally, the people I trained last year for 205 exam, we trained ourselves both on 205 and 315. The day we saw the exam self, we were able to do, not even, if not all, we attempted at least 3 questions out of, I don't know how many they asked you to do. I think 4 out of 6 now. We did 3 questions. So it's just the same thing. I get what I'm saying like that. So anyone that is 205 should just come inside and let's learn together. What I want to do now, once it is, I just want us to use this time to chillax, and so once it is 23 now. So once it is 23 now, we can just start straight to with questions. And I promise us that by the end of today we should be able to look at how many did we promise ourselves? 50. Okay, let's say 40 to 50. And I'm going to solve them now. And I'm going to solve now, you go right. Why would they complain like this? But when they see that they stand up and they talk. Alright, so please take care of yourself, right? So this time around, calm down now. Okay, I want to clean the board now. So all 205% around anywhere, you are welcome to sit down. It's just a continuation of a class. All 205 that are around, you are welcome to sit down. It's continuation of of a class. And I'll start the questions from separation of variables. I'll state it. Then from separation of variables, we look at homogeneous, we look at linear, Bernoulli, exact. So let's start. Yeah, please, let's have our seats. Quietly, peacefully, gently. Sit down, sit down, sit down, sit down. Ready? Yeah. Alright, good. Let's start. So now, let's look at this first question, and it's under separation of variables. So as I've said earlier on that, how do you recognize separation of variables? See, solving differential equations is not hard. The problem is recognizing what law to use at a particular time is the problem. There are some questions that you might, that question will exactly look like problems like, there are some, okay, for example, if you are dealing with linear and Bernoulli, if you have not practiced hard enough, you might mix them together. And one thing about CBT is that you don't have time to waste. I get what I'm trying to say like that. You don't have time to waste. Yes, written. You don't have time to waste. So it is best you practice well and you can adapt. So once you see a question, you know that, okay, this one is what? Linear, this one is what? Bernoulli, this one is what? Exact. So at any question you see, you know what to do at that part. I'll get what I'm trying to say like that. So it's easy. So now, how do we recognize separation of variable? I'll say it again. Separation of variable will be written in such a way that it will be very easy to separate what? Y from X. Very, very easy. I guess what I'm trying to say like that. That's how you will know it. It will be very easy. For example, this example that I have on the board here, you notice that Y and X are completely separate from each other. Y is not in X, X is not in Y. I guess what I'm trying to say like that. So this is an example of what? Separation of variable. Then from here, how can I solve it? Let's say I cross multiply. But this my cross multiply will be incomplete in the sense that this one here will come here, this one here will come back here. I'll get what I'm trying to say. So for me, I can now have dy multiplying 1 over square root of 1 minus y squared equals to dx multiplying square root of 1 minus what? X squared. Then from here, what do? You integrate both sides. So from integrating both sides, so what do I have? I have integral of what? 1 over square root of 1 minus y squared dy equals to integration of 1 over square root of 1 minus x squared what? Dx. Now from here, what do you notice? Notice that this one here, if you integrate this one here, this is the same thing as talking about what? Sine inverse of what? Of y. Yes or no? Because I told you that whenever I want to integrate sine inverse, it should be what? 1 over square root of 1 minus x squared. Yes or no? Good. Then is equal to what? Sine inverse of what? X plus c. And I told you that whenever you have a question that requires you to differentiate, to integrate y and x at the same time, where are you adding your arbitrary constant? Add your arbitrary constant to the what? To the x side. Do you get what I'm trying to say like that? So with this now, I am what? I am done. See that it's not hard. Know what you are supposed to do. Everything is what? The same thing. This one here. Like what I just did was, it's like cross multiplying, but I did not just finish it. This one here moved here, and this one here moved here. They just swap. No, I didn't do it. I didn't touch this side. I just touched the other side. I just feel, because it will be easier for me. I want it to be fast. If you wanted to do it the normal way, then what we have had here, you will have had probably dy equals to square root of 1 minus y squared over square root of 1 minus x squared dx. Then you divide both sides again by this. You get what I'm trying to say like that? Then you'll have still given you what I have here. Still have the same answer. So I'm done with the first question. So let's look at another question. Number 2. Sec squared x tan y dx plus what? Sec squared y tan x dy equals to what? 0. So let's look at this now, this time around. Now, this case, I don't even have a dy dx present. That means first of all I have to create a dy dx. How do I create it? Carry everything that is here to the other side. Then what do I have? I have sec squared y tan x dy equals to what? Minus sec squared x tan y dx. Then what do I do again? Divide both sides by what? Dx. Then you can have what? Sec squared y tan x dy over what? Dx equals to what? Minus sec squared x tan what? Tan y. So from here, or it shouldn't even have mattered, even if I had cross multiplied from this part here. Because what is the goal? The goal is to make sure that I'm writing all x on one side and all y on the other side. So what do I do here? This is x here, x is here, x is here, tan y is here, tan y is here. So what do? I can say that, let me divide both sides by what? Tan y. Dividing both sides by tan y, what will I have? I will have sec squared y over what? Tan y tan x dy equals to what? Minus sec squared x dx. The next step is what? Divide both sides by what? Tan y. You can now have sec squared, tan x over tan y dy equals to what? Minus sec squared x over what? Tan x dx. I'm getting it now. So I have successfully separated x and y on their different sides. Then from here I can say that I'll do what? I'll integrate both sides. Integrating both sides will give me integral of sec squared y over tan y dy equals to minus integration of what? Sec squared x over what? Tan x dx. Then from here, what do I have? Notice that this time, if you differentiate the denominator, you end up having what? Your numerator. Yes or no? So now, from that, I can answer that the answer is what? Ln of what? Tan y is equals to minus ln of what? Tan x plus what? C. And I said specifically that whenever you are having ln on both sides, what do? You take exponents. So now, taking exponents, so take exponents of both sides. Then what do I have here? I'll have exponential ln tan y equals to what? Exponential minus ln tan x plus what? C. Then which is the same thing as saying tan y, because exponential and ln will cancel out to give you, this is same thing as saying exponential minus ln tan x multiplied by exponential c. And you can say that what? Exponential c is equals to what? A. So from here, what will I have? I can have tan y is equals to exponential. This my minus here can come crossover to give me tan x raised by what? Minus 1 multiplied by what? A. Then moving up here, what do I have here? You find out that this one will give me what? Tan y equals to 1 over what? Tan x multiplied by what? A. Then multiply everything here by what? Tan x. Then your answer is what? Tan y tan x is equals to what? A. That's my final answer. So from here, another one, exponential y plus 1 cos x dx plus exponential y sin x dy equals to what? 0. Okay. From here, how do I recognize what to do? And the thing that you recognize here is that, as I said, I don't have dy dx. So what do I have to do first? Create dy dx. So let's create a dy dx here. So by creating dy dx, what do I have? Carry this one to the other side. So which will give me exponential y sin x dy, are we together? Equals to, what would I have? Minus exponential y plus 1 cos x, what do I have here? Dx. So now I want to try as much as possible to separate what? X and what? And y. So what do I do first of all? I divide both sides by what? By sin x. Dividing by sin x will give me what? Exponential y dy equals to what? Minus exponential y plus 1 cos x over what? Sin x dx. The next time, for me to remove that part, what do? I divide both sides by what? minus exponential y plus 1. Yes or no? Then what can I now have? I will have exponential y divided by what? Or let me just leave the minus there. Exponential y plus 1 dy. Everything with this minus cos x over what? Sine x dx. Are we together? Then from here, what do I do next? I what? I integrate what? Both sides. So by integrating both sides, what do I have? I have integral of what? Exponential y over exponential y plus 1 dy equals to minus cos x over sine x dx. Are we together? And so from here, you will find out that if you differentiate your denominator, what will I have? Your numerator. Yes or no? So from here, what will I have? ln of what? Exponential y plus 1 equals to minus, because if you differentiate sine x, what do I have here? Cos x. That will give me what? Minus ln of what? Sine x plus what? Plus c. This minus here can cross to give me what? Ln exponential y plus 1 equals to what? Ln of sine x raised to what? Minus 1 plus what? Plus c. And what do I have on both sides? I have what? Exponents. I have ln on both sides, so I'm taking exponents. So I can say that exponent ln exponential y plus 1 equals to what? Exponent ln sine x raised by what? Minus 1. I hope you know that by the time I take exponent, this will give me exponential c. Yes or no? Okay, good. And for me, don't forget that exponential c is equals to what? A. And for me, I can now say that exponential y plus 1 is equals to what? 1 over sine x multiplied by what? A. And what is 1 over sine x? 1 over sine x is the same thing as saying exponential y plus 1 equals to what? A cosec. Have you now? A cosec what? X. Okay, sorry. Like plus 1. Sorry. Plus 1. So plus 1. Okay, good. Okay, that I cross my sine x to the other side. It's still the same thing. So it depends on how, but the thing is that just try as much as possible to write your answer in the what? Most simplified state. I think this one is simplified enough for me. If I like, I can multiply everything by what? By sine x as I want. So anyhow I like, that's how you can treat it. Now, okay, another question. So let's look at this now. The next thing we have to do here is what? As usual, try to do what? Try to separate them, right? So now, this time around, let's try something new. Now, so far so good. Everything I've been moving was always dx, dx, dx. Yes or no? This time now, I'm not moving dx. I want to move what? I want to move dy. So what do I have here? I will have 3 exponential x tan y dx give me what? Minus open bracket 1 minus exponential x sec squared y dy. And I hope you know that this will still give me 3 exponential x tan x dx. If I use this minus to open the bracket, what will I have here? Exponential x minus 1 multiplied by what? Where? Okay, tan y. Alright. Then plus sec squared y dy. Are we together? And so from here, as usual, try to do what? Separate them. So how do I separate? So let me divide. So I can have 3 exponential x over exponential x minus 1 tan y dx is equals to what? Sec squared y dy. Then divide both sides by this. So I have 3 exponential x over exponential x minus 1 dx is equals to what? Sec squared y over what? Tan y dy. And from here, what do? What? Integrate both sides. By integrating both sides, I have integral 3 exponential x over exponential x minus 1 dx equals to what? Integral sec squared y over what? Tan y dy. I hope you know that this 3 is a constant. So if I remove the 3 outside, you find out that if I differentiate exponential x minus 1, I still have what? Exponential x. This one will give me what? 3 ln of what? Exponential x minus 1 equals to what will this one give me? Ln of what? Tan y plus what? Plus c. Then from here, take this 3 back. They can have ln of what? Exponential x minus 1 raised to power 3. And is equals to what? Ln of tan y plus what? Plus c. And from here, what do? Exponent both sides. If I exponent both sides, I have exponent ln exponential x minus 1 raised to power 3 equals to what? Exponent ln tan y multiplied exponential c. And the final answer here is what? Exponential x minus 1 raised to power what? 3 is equals to what? Tan y or a tan y, better still. A tan y, that will be my answer. I hope you are getting this, please. Yes? Oh. Thank you for the observation. You can do it anyhow. Like, yes, thank you. You know that normally my c was always supposed to be with x. But now I think I added it to y in this case. So if you add it to x, you will still get the same kind of answer, but it might not just be 100% equal. Like, don't get what I'm trying to say like that. So if I use the other way around, what I would have had here will have been exponential x minus 1 raised to power 3 multiplied by what? A equals to what? Tan y. It's just you have the same number of things that you have there, but the only thing that will change will be your what? The movement of your a and the movement of your constant. Both are correct now. See now? This. The only difference is that a is here and the other one what? A is on the right hand side. So that's why I just say that it's not that both of them are not correct. It depends on the marking scheme that person is using. So that's why I say that most of the time it's just mostly advisable to put your a to your what? To your x side. It's just mostly advisable. Because that is what most people do too. Do you understand? But this is what you have. If you say, the guy asked the question, if you say I added a to this side here, this will be my answer. And you find out that it is the same thing, but the only difference is what? The movement of a. I get what I'm trying to say like that. So please, next time you are integrating x and y, try to add your what? A to your what? Add your arbitrary constant to your what? To your x. Do you get what I'm trying to say like that? Okay, good. So I hope by now, I don't think there should be anybody that doesn't know how to even attempt this one now, by now. Abi now, I don't think there should be anybody that don't know how to attempt this by now. What will I do in this case? Now move either dx or dy to the other side. But it is easier for me to move what? Dx because it's already negative here. So going to that side does make it what? Positive. I can have here to be xy plus x dy equals to what? Xy plus y dx. And for me, if you remove x here, what do I have? Y plus 1 dy. Remove y here. Y equals to what? X plus 1 dx. Are we together? And so from here, how do I divide? Bring this one here, bring this one here. So at the end of it, I can have y plus 1 over y dy equals to what? X plus 1 over x dx. Yes or no? Aha. And from here, what do I do now? Integrate what? Both sides. By integrating both sides, what do I have? I have integral. Do you know that this one here can still be written as y over y minus plus 1 over y dy equals to x over x plus what? 1 over x dx. Yes or no? And this one here is equals to what? 1 plus 1 over y dy equals to 1 plus what? 1 over x dx. And from here, if I integrate y, what do I have? Y plus, integrate this one will give me what? Ln y equals to, integrate this one, I have what? X plus ln x plus what? Arbitrary constant what? Of c. So I think that will be that about that. For what? For separation of variable. Okay, I think that will be that about that for what is it called? For separation of variables. I hope you are all clear on separation of variables now. Okay, good. Now, next one. And this time around, I want to find out, now I want to move on to homogeneous. Now, as I said, the main key you need to know is how to recognize homogeneous. I will have to recognize what to do at a particular time. I guess what I'm trying to say like that. So now from this side here, so now, and another thing is that homogeneous equations are written in such a way that you can never separate x from y. So you're going to approach it like that. You cannot separate x from y, so that one cannot even prompt you to say that you want to use what? Separation of variable. So you're going to approach it like that. So from here, let's go at this question. First of all, this question, I don't even have a what? I don't even have a dy dx. So let's find that. So what do I do here? I can have, say, x squared plus y squared dy over dx is equals to what? Xy. Dividing this by this, I can have dy over dx equals to what? Xy over what? S squared plus what? Y squared. All together. Then after you have done this, the next thing you're going to do is that whenever you have this situation, next thing is what you say, put y equals to what? Vx, equation what? Equation 1. Call that a particular equation. That means anywhere you see y, you substitute what? Vx inside. So that will give you what? The y dx, which is equals to what? X multiplied by what? Vx over what? X squared plus what? Vx all squared. And everything here is still the same thing as saying Vx squared divided by x squared plus what? V squared x squared. And the y dx here is equals to, what is common here? X squared. So I have what? V over x squared, which is what? 1 plus what? V squared. How getting it, please? And this one can cancel out. I can say that my dy dx equals to what? V over 1 plus what? V squared. Are we getting it? So moving down here, I can now say recall that y equals to Vx. So if I differentiate, so differentiating both sides now, what do I have? Differentiating both sides will give me what? Dy dx by product through here, u and v. So what do I have here? V open bracket 1 plus x. If you differentiate v, what do you have here? The v dx. You can now say that dy is equals to what? V plus what? X dv d what? Dv dx. Are we getting it, please? And so from here, sorry, this is the y dx. So from here, I can now substitute this answer instead of what? This one here. And what will I have? I will now have, instead of the y dx here, what will I have? I will have v plus x dv dx is equals to what? V over what? 1 plus what? V squared. Yes or no? Now the next thing I can do here is what? Is to move this v to the other side. So I can have x dv dx equals to what? V over 1 plus what? V squared minus what? V over 1. Then from here you have x dv dx equals to 1 plus v squared v minus v open bracket 1 plus v squared. Hope you guys know how to talk. Okay, good. Then here you can now have x dy dx here equals to v minus v. Have you now? Okay. The v dx. You give me v minus v cube divided by 1 plus what? V squared. And for me, you can have what? Dx dy dx here equals to what? Minus v cube over what? 1 plus what? V squared. Are you getting it? Then from here, then let's now continue from that part. Let me write that part back up here, which is what do I have? X dv dx equals to, what is the other part now? Which is minus v cube over what? 1 plus what? V squared. And so from here, what do I have to do? I have to separate v from x. Yes or no? Let's do so. So by cross multiplying, what do I have? I have x dv equals to v cube over 1 plus v squared dx. Yes or no? Take this one to the other side. I can have x open bracket 1 plus v squared is minus here dv equals to what? V cube dx. Yes or no? And I can divide both sides by x v squared. So x v cubed. So I can have, that's minus here. And I have 1 plus what? V squared over what? V cubed is equals to minus 1 over x dx. There's also a dv here. Do you get what I'm trying to say like that? Then from here, if I split this, I have what? 1 over what? V cube plus what? V squared over what? V cube is equals to what? Sorry? dv is equals to what? Minus 1 over x dx. And this one is the same as saying v is by minus 3 plus what? 1 over v. Everything enter what? dv equals to what? Minus 1 over x dx. Are we getting this, please? Then from here, what do I do? From here, what do I do? I integrate both sides. So I integrate both sides. So by integration, I have v minus 3 plus 1 over v dv equals to integration of minus 1 over x dx. So by integrity, v is by minus 3, kin magba. I'll call it have v minus 3 over, minus 2 over minus 2 plus, if I integrate 1 over v, what do I have? I have what? Ln v equals to, what do I have here? Minus ln x plus what? Plus c. Then I think it's the best for me to multiply everything by what? By minus 2. So I can have v minus 2 plus what? Plus minus 2 ln v equals to minus 2 times this one will give me what? That's 2 ln what? 2 ln x. And from here, plus c, and this one now gave me 1 over what? V squared equal minus 2 ln v equals to what? 2 ln x plus what? Plus c. Yes, the 2 is not supposed to, we don't know what type of c it is yet, whether it is a 0, whether it is infinity, or whether it is a valid number. So let's just leave the c like that. Now that if the c is 0, if 2 multiplied, will still give us what? 0. So there's a tendency that that c can be 0. So let's just leave the answer like that, without the 2 multiplying the c. Then from here, what will I have? Then from here, I was supposed to leave my answer like this, in this format, but I have a v here. And if you remember, my question was not written in terms of v. My question was written in terms of what? X and what? And y. I can now say that, recall that v equals to, y equals to what? Vx. And from this case, v is equals to what? Y over what? X. So put this answer inside this space. So I have what? 1 over y over x all squared minus 2 ln y over x is equals to what? 2 ln x plus c. Then this one here, it will be the same thing as writing x squared over y squared minus 2 ln y over x equals to what? 2 ln x plus what? C. Will be the answer. Another asking questions? If you made it v raised by minus 1, then you'll have been left with integration of v raised by 0 over 0, which will have been undefined. So in order for you to avoid undefined, anything raised by minus 1 is the same thing as taking the ln of that thing. Shake up. Okay. So from here, I can start. First of all, let's start with our standard stuff. What is our standard thing that we're doing first? Y is equals to what? Vx. That's the standard stuff. And for me, I can have the y dx here is equals to what? x squared minus vx all squared over what? 2x multiplied by what? Vx. Then your dy dx here will give you what? X squared minus v squared x squared over what? 2vx squared. Are we together? Then from here you have what? Dy dx is equals to what? X squared open bracket 1 minus what? V squared divided by what? 2v. Yes or no? Then 2vx squared. X squared can cancel your x squared. Then you have what? Dy dx is equals to what? 1 minus v squared over what? 2v. I'll go to what I'm saying, please. Then from here, what do? You cross multiply. So by cross multiplying, so the next one here is for you to what? Okay, before you split them, you can also recollect that and be like, but dy dx is also equals to what? V plus what? X dv d what? Dx. Yes or no? Yeah. So then I cannot substitute that here. Then I can answer that. Therefore, here I'll have v plus x dv dx is equals to what? 1 minus v squared over what? Over 2v. Then from here, take v to the next term. So I have x dv dx equals to what? 1 minus v squared over 2v minus what? V over 1. And x dv dx is equals to what? 1. LCM is what? 2v. 1 minus what? V squared minus what? 2v squared. And I have what to be 3. Sorry, not 3 now. X dv dx should be giving me 1 minus what? 3v squared over what? 2v. Then by cross multiplying, what do I have? X dv multiplied by 2v equals to 1 minus 3v squared multiplied by what? Dx. And what do? Divide both sides by x this. So I can say that I have 2v over 1 minus 3v squared dv. All together? Then equals to, what do I have here? 1 over what? X dx. So from here, what do? Integrate both sides. So what do I have? I have integral of 2v over 1 minus 3v squared dv equals to integration of what? ln of x plus c. Now from here, what do you find out? You find out that if you differentiate what is in this your denominator, you're supposed to have something that is similar to your numerator. So if I differentiate 1 minus 3v squared, what will I have? Minus 6v. But out of that minus 6v, what do I have in my numerator? 2v. So what is the name, the thing that's remaining there? Minus 3 itself. So I can answer that because of this, the answer will now give us minus 1 over 3 ln of what? 1 minus 3v squared equals to, what do I have here? Wait, okay, I've already integrated it. Ln of x plus what? Plus c. Then let's take this to the other side. Then I can have what? Ln of 1 minus 3v squared over minus 1 over 3 equals to what? Ln of x plus what? Plus c. And from here, if you take exponent of both sides, you can have exponent ln 1 minus 3v squared over what? Minus 1 over 3 equals to exponential ln x dot exponential c. This one will have now 1 minus 3v squared over minus 1 over 3, which is what? X exponential, no, or let me just say ax. Then from this part here, I'll cube both sides. So cubing both sides here will now give me 1 minus 3v squared equals to what? Ax cubed. Then if you swap it, then you can have 1 minus ax cubed equals to what? 3v squared. Therefore we have 1 minus ax cubed equals to 3. What is your v squared? y over x, everything is what? 3 squared. Then I have 1 minus ax cubed equals to 3y squared over what? X squared. Then cross multiplying, you can have x squared minus ax to the power of 5 equals to what? 3y squared. That'll be my answer. Whatever you have, try as much as possible to write your answer in what? The most simplified state. Please, do we get? Please, do we get? Okay, good. While I wait for us to write. So let's look at another example. How many examples have we done so far on homogeneous? And 2. Yeah, it's usually very, very long, but it's worth knowing too at the same time. Okay, let's look at another example now. Okay, 3xy plus y squared over 3x squared. Now, I want to deal with this now. To deal with a question like this, how do we start? It's very, 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 very simple stuff. And we start like this, which is, what is the first step here? What is the first step to do? The first step is what? To represent what? Y equals to what? Vx. And I can say that y here equals to what? Dx. Now for me, I can now say that dy dx is equals to 3x multiplied vx plus what? Vx all squared divided by what? 3x squared. Then here, dy dx here will give me what? 3vx squared plus v squared x squared over what? 3x squared. Therefore, me, I can have dy dx, which is equals to what? X squared open bracket what? 3v plus what? V squared over what? 3x squared. X squared will cancel x squared. I can have dy dx equals to what? 3v plus what? V squared over what? Over 3. Yes or no? Yes or no? So I've gotten that part. The next part that I'm looking for now is so from here, if we have to move from this place, what will be the next step after I've gone to this particular point now? Next step to replace that dy dx with our normal derivative, yes or no? I can now say that here, but dy dx is equals to what? V plus what? X dv over what? Dx. Therefore, then what will I have here? V plus x dv dx would give me what? 3v plus what? V squared over what? Over 3. Taking this one to the other side, you have x dv dx equals to what? 3v plus what? V squared over 3 minus what? V over 1. Then for me, what do I have? I have x dv dx equals to what? 3v plus what? V squared. No. What's the LCM here? 3. That would be 3v plus what? V squared minus, what do I have here? 3v. And at the end of the day, I have what? X dv dx, which is the same thing as what? v squared over what? Over 3. So I think by cross multiplying, playing around this stuff, then I can have 3x dv equals to v squared dx. Yes or no? Then from here, and how do I do it? Probably I just say differentiate both sides by, divide both sides by what? X and v squared. So I can have 3 over v squared dv equals to what? 1 over x dx. Then this one here is the same thing as saying 3v is by what? Minus 2 dv, which is what? 1 over x dx. So what do I do here? I integrate both sides. What you are writing is not note. Please pay attention and learn. If you get what I'm trying to say like that. So now from here, I'll now integrate. So to give me 3v minus 2 dv equals to integration of 1 over x dx. And from here, so if I integrate 3v minus 2, what do I have here? I'll have minus 3v minus 1 over minus 1 equals to what? 1, ln x plus c. And you want to write this one very well. Abi? Minus will not be down here. Now this one is still the best at writing that. Minus 3 over what? V. To give me what? Ln x plus c. But don't forget that v is equals to what? Y over x. So that will give me minus 3 over what? Y over x equals to what? Ln x plus c. Then your final answer will give what? Minus 3x over y equals to what? Ln x plus what? C. That's my final answer. People are just writing notes. You're not writing notes too. Yes, sir. Yeah, it's a kind of substitution that we do or we use whenever we have to deal with homogeneous equations. Like, just like, whenever I want to solve for acceleration due to, motion due to gravity, if the equation does not include g, you find a way that there should be a g in it. You're gonna pencil like that's the same scenario. That even if you are dealing with homogeneous equation, and you want to solve it, the best way you have to do is what? Is to introduce what? Y equals to Vx. It's like a standard formula procedure. So you get one pencil like that. So that's why. So I think I'm done with that part. So now another question. I'm tired. I'm tired though. Alright. Another one. dy dx is equals to tan y over x plus y over x. So now this one here does not look as if it will stress me in one bit. Do you know why? This one cannot stress me. Or will it stress us? Can this question stress us? No, you're supposed to know by now. This question can't stress us. Because do you know that, don't forget that already you know that v automatically is the same thing as what? Y over x. Then you can just substitute it inside. So which will now give you dy dx is equals to what? Tan v plus what? V. And what is your dy dx in terms of v? That would be what? V plus what? X dv dx equals to what? Tan v plus what? V. Take this one to the other side. Then what do I have? I think I will have x dv dx equals to what? Tan v. When I told you that you cannot stress us, you were looking as if it will stress us. It's too simple. Okay, I love you. I love the confidence. It's good actually. Math is not hard. Math's no hard now. Math's no hard. Maybe a math you can't do for 4 days like this. Math no hard. Have you now? I hope you know why this one is tan v here. Do you know why it's tan v? Because I already have plus v, then if this plus v cross to the other side, then I have what? Minus v. And so by now, I want to jump. Whether you understand or not, you're supposed to understand now. I want to jump. So from here, jumping, I know that by the time I will jump, I will have cot v. The v equals to 1 over x dx. You can, it's the same thing. You don't understand. Alright, let's take it from this part here. So for me, let's cross multiply. So what will I have? I will have x dv equals to what? Tan v dx. Yes or no? Then splitting both sides. What do I have? I have x dv over what? Tan v equals to what? Dx. Then this one here will give me what? V over what? Over tan v equals to what? Dx over what? X. And 1 over tan v, which is here, it's the same thing as saying cot v dv equals to what? 1 over x dx. You have not seen how I jumps now. Then from here, what do we do? Integrate both sides. So by integrating both sides here, what do we do? Integral. So let's rewrite that cot. Cot will be cos v over what? Sin v dv equals to what? Integral what? 1 over x dx. And at the end of this day, what will this one give me? This one will give me what? Integral of what? No, it's not. It won't be any integral. It will be ln of what? Sin v is equals to what? Ln of x plus what? C. Then from here, I told you, what can I have from this space? Exponent ln sin v equals to what? Exponent ln x multiplied by exponential c. Yes or no? Yes, sir. And so from here, you can have what? Sin v equals to what? Ax. But don't forget that v is equals to what? Y over x. Then your final answer will be what? Sin y over x is equals to what? Ax. I believe by now we should have been familiar with how to differentiate differential. Because if you differentiate sin v, you get cos v. And if a differentiation, if that condition happens, then the answer to that your integration will be the ln of your denominator. Yes. I did not do magic. So the next differential equations that we're looking at now, next method, let's look at linear. So that's number 3, Abby? Is that number 3? That would be what? Linear differential equation. EQN. Thank you. Can't waste time. Now, with this equation, first thing I wanted to know is that I will just help you to write out the normal format with which it's supposed to be. I get on apparently like that. So whenever you are having, I will have to prove it for you so that you understand very well. Okay, let's prove. Let's do a little proof. Then we'll do examples. Is that okay? Okay, let's do a little proof. So from here, how do you recognize linear differential equation? They're always written in this format: dy dx plus p of x y equals to what? Q of what? X. This is how all linear differential equations are always written. Now, so if you've gotten this, then the next step you will have here would be that you find your integrating factor. I'll go to I'm trying to say like that. So you find your integrating factor, and your integrating factor is given by exponential integral p of x dx. Are we together? So that's like a step. What is step 1? Step 1 is that make sure that your differential equation is written in this format. Step 2 is what? Find your integrating factor, which is given by this formula. Now, what will be step 3? The step 3 will be, let me call this one equation 1. So multiply equation 1 by integrating factor. So what will I have there? I think I will have everything here, dy dx plus p of x y multiplying integrating factor equals to what? Q of x multiplied by what? Integrating factor. I get what I'm trying to say like that. We're just writing the steps one by one. What is the first step? I said that the first step is what? After you have make sure that your differential equation is in this type or in this method, and the next one you are going to what? Find your what? Integrating factor, which is written in this formula. And the next one that you do is what? You multiply your original equation by what? Integrating factor, which will give you this. Then from here, everything here automatically, I don't want to expand it. Everything here automatically gives you d dx of what? Y multiplied by your what? Integrating factor equals to q of x multiplied by what? Your integrating factor. Just know it like that. Do what? Just what? Just know it like that. I can prove it, but just what? Just know it like that. Let me save you of the proof. Do you understand? So don't forget that after you have multiplied your original equation by your integrating factor, what will be the next step? Next step will be for you to write d dx of what? Y multiplied by your what? Integrating factor. Don't forget. Do you get what I'm trying to say like that? Let me repeat it again. After you have multiplied by your what? Integrating factor, the next step is for you to what? Write d dx, which is equal, d dx of y multiplied by what? Integrating factor. Do we understand? So from here, then how do I find? Then I multiply both sides by dx. That'll give me dy multiplied by your integrating factor, which is giving me as q of x multiplied by your integrating factor, then multiplied by your what? Dx. And from here, you integrate both sides. dy times your integrating factor equals to integration of q of x multiplied by what? Integrating factor, then multiplied by dx. And at the end of the day, integration and d will cancel out to give you y multiplied by your integrating factor, which is equals to what? Q of x multiplied by 1 multiplied by what? Integrating factor. Don't forget integral here, dx. So this is the old methodology for you to solve a linear differential equation. Let's go over it one more time, step by step. Now, what is the first thing? Ensure your linear differential equation is written in this form. Now, the next thing is for you to write your what? Find your integrating factor. And what is the formula of your integrating factor? Exponential integral p of x dx. And after you have gotten your integrating factor, then the next step is to what? Multiply your original equation by what? Integrating factor. And after you have multiplied your original equation by your what? Integrating factor, the next step will be that write d dx of what? Y multiplied by what? Integrating factor. Then from here, multiply both sides by dx, then carry suit as you always differentiate normally. Do you understand what I'm trying to say like that? Okay, good. Now let's take examples on it. All right. This first question. Now the first thing that we have to check is that, let's check, is this question written in the order of my linear equation? Is it written, is it the same thing? So that means it's the same thing, 1 over x, and my q of x here is equals to what? X cubed minus what? 3. Are we together? Then the next step is for you to find your what? Integrating factor, which is what? Exponential integral p dx. Are we now? Which is what? Exponential integral 1 over x. Are we now? Dx. And your integrating factor will give you exponential ln x. Yes or no? And don't forget that exponential and ln are not friends. So your answer here is what? X. So integrating factor here is what? X. The next thing is what? Multiply, let me call this equation 1. Multiply equation 1 by what? X. So what do I have here? I have dy dx plus what? 1 over xy multiplied by x equals to what? X cubed minus what? 3, everything multiplied by what? X. Are we together? Then so by using x to open this bracket, what do I have? You have x dy dx, are we together? Plus 1 over x here, we cancel this x here to give you what? Y, which is the same thing as what? S to the power of 4 here minus what? 3x. Yes or no? And so from here, don't forget that after you have multiplied with your integrating factor, what's the next one? D dx of what? Y multiplied by your what? Integrating factor, which is equals to what? X4 minus what? 3x. And the next step is for you to what? Multiply both sides by this, so you can have d open bracket xy equals to x to the power of 4 minus what? 3x dx. And from here, I will what? Integrate both sides. You see that for all the steps that I'm doing, I'm writing it. I'm not writing it because I love to write. I'm writing it because I'm programming you to know how to write it in exam. Because if you are this type of person that, I know you know it, you sabi book a lot. But if you are jumping step, fine boy, you'll be losing mark. Who be assist, Abek? So please, I'm telling you, it's more than you knowing it. You have to take your time, although you have to be fast. But for everything you are doing, write your what? Write your step. Write it out. So now integrate both sides here. So what do I have? I have integral of what? D open bracket xy, which equals to what? Integral of what? S to the power of 4 minus x dx. So what will happen here? I'll have what? Xy equals to, if I integrate x to the power of 4, what do I have? X to the power of 5 over 5 minus what? 3x squared over what? 2 plus what? C. Divide both sides by what? By x. So I can say that y is equals to what? X to the power of 4 over 5 minus what? 3 over 2x plus c over what? X. That's my final answer. Do you understand? So as I've said, everything. Y? Yes, y times your integrating factor. I'm following that procedure. Should grab. Can we continue? Okay. So how many questions so far? Plus this one? 11. Huh? Everything plus what I've... This is 11th one. Alright, let's continue. So in this case, what do you notice? This time around, I don't even have a dy dx. And it's linear, and it's linear. So what do I have to do? I have to find dy dx. What do I have to? So the best way is for me to take everything here to the other side. So I can have this one to be x dy equals to what? Minus open bracket 2y minus 3x dx. Yes or no? Then you can have x dy, which is equals to, use minus open bracket, and you have what? 3x minus 2y. Everything here is what? Dx. Yes or no? Divide both sides by what? Dx. So you have x dy over what? Dx equals to what? 3x minus 2y. Okay, I think that's all about that. Then from here, divide everything by x. So dy dx should give you what? 3 minus 2 over xy. Then bring this one to the other side. You can have dy dx plus what? 2 over xy equals to what? 3. So I have successfully written it in what format? In my linear format. Yes or no? Now for my linear format, I can now ascertain which is my p. What is my p of x here? My p of x is what? 2 over x. Or, yeah, 2 over x. Or better still write it in this form. 2 open bracket 1 over x. I think it's still better. And what's your cube of x here? Your cube of x is what? It's 3. Yes or no? I mean, no. Then, so what's your integrating factor? Integrating factor is to what? Exponential integral 2 open bracket 1 over x. I mean, no. Dx. And this will give me integrating factor is what? Exponential 2 ln x. Let this 2 come back here, which is what? Exponential ln x squared. Exponential and ln will cancel out, so your integrating factor here is what? X squared. So I've gotten your integrating factor to be what? X squared. I've got the integrating factor to be x squared. So the next thing that is left here is what? Let's call this one. Now, which equation will I use? I think this would be the best equation to use. Now, this would be the best to use. And I'll say that multiply equation 1 by what? By x squared. So what do I have here? I'll have dy over dx plus what? 2 over x y. Everything here is equal, x squared, which is equal to what? 3x squared. Yes or no? And for me, what do I have? I have x squared dy dx plus what? 2 plus 2xy, which is equal to what? 3x squared. Yes or no? And everything is what? D dx of what? Y multiplied by what's your integrating factor? X, which is equal to what? 3x squared. Then multiplying your d or x here, so you have d open bracket y x squared equals to what? 3x squared dx. Are we together, please? Please, am I carrying everyone along, please? Okay, good, let's do come. Yes, is there an issue? Yes, ma'am. Okay. And so from here, what do I do here? I integrate both sides. So I integrate both sides. So from integrating both sides, what do I have then? And I have integration of what? D open bracket yx squared equals to integration of what? 3x squared dx. Whatever I integrate this, I have what? X squared y, which is the same thing as what? 3x cubed over 3 plus what? C. Yes or no? Then I can have what? X squared y equals to what? X cubed plus what? Plus c. If you answer like this, or you can decide to divide through by what? By x squared if you want. You get some apprenticeship, please. X plus 1 divided by x minus 2 minus 4. All right, another question. Yes, that is not that y times x squared is based from this. Yes. Yes. After this is from here. I told you that after you have multiplied by integrating factor, next thing is what? D dx of what? Y multiplied by your integrating factor. Look as if I'm a little bit fast, Abby. Kind of. The thing is that I want to finish everything with you. I know that when next you meet for 2.5 or 2.9, we're entering straight up to second order. And after second order, then you do Laplace. And after Laplace, you now do PD. I'm waiting for us to write fast. Please do understand what I've been doing since morning, please. You're just coming, Abby. We. That is. I don't know what we can do. Please, you can help her, please. I've gone too far to come back. Bolu, you're my helper, Joe. Please help me. Joe. Please, ma, if you are done, please see him. Look at me, we buy now. I think out of everyone that is here, who is he? Let me see. Let me look at. I still trust him more out of everyone that is here. And I've known Bolu since when himself. I'll take point now, about 100 level. So yeah, I'm waiting for you guys to finish it that we can round off. And after we are done, we'll probably do 2 more examples on linear so that you can master the form very well. Then we'll move on to what? Bernoulli. And after Bernoulli, we'll treat what? Exact. And after exact, you have 45 minutes, about 45 minutes, and you can with your respective house. I hope you are with the timetable now. I've been now. On another day with timetable. Don't worry, you get the update of next timetable later. Alright, I'm waiting. And now you're going to party and by. Yeah, I'm waiting. It's nice to see your face around, Oh yeah, I beg. Don't write fast, I beg. Who is still writing, please? Nobody. If you are writing, up your hand. Yeah, I give you, see. If this time enter 16, I will start working. I don't know how I want to do it. If you enter 16, I start working. If you enter 16, it's on 30 now. Yes, sir. See, if you like ask me a question, that does not mean I should not continue. But I'm just joking, literally, yes. This is DIF now. I've already multiplied it. Before it was 3. Uh-huh. 58, 59, 16. Time is up. So now from here, what is the first step? First step is to write it in such a way that the y dx can stand what? Alone. So what do I need to do to that? Divide everything by what? X plus 1. So I can say that the y dx here is equal, minus what? 2 over x plus 1 y is equals to what? X plus 1 raised to the power 4 over what? X plus 1. Then from here, what will I have? I will have the y dx minus what? 2 over x plus 1 y equals to x plus 1 raised to the power what? 3. Are we together, please? Then from here, what is your p of x? Your p of x is equals to minus 2 over x plus 1, and your q of x is equals to what? X plus 1 raised to the power 3. And so from here, your integrating factor, which is equals to what? Exponential integral minus 2 of x plus 1 dx. I hope you know that this one will give me what? Exponential minus 2 ln of what? X plus 1. Are we now? X plus 1. Then this minus 2 can come back here to give me what? Exponential ln x plus 1 to the power of what? minus 2, and everything I can cancel out to give you what? Your integrating factor is what? 1 over x plus 1 all squared. I've gotten my integrating factor here, so what will be the next step? Next step is what? Multiply, let me call this one equation 1. So multiply 1 by what? By integrating factor. So what will I have if I do that? And what will I have if I do that, if I multiply? I think at the end of the day I'll be having, this is what I want to multiply with, so I have dy dx minus what? 2 over what? X plus y raised by y. I always get that. And everything multiplied by what? What is your integrating factor? 1 over x plus 1 all squared equals to what? X plus 1 raised to the power 3 times what? 1 over what? X plus 1 all squared. And opening the brackets, you can have 1 over x plus 1 all squared dy dx minus 2 over what? X plus 1 3, I mean now, y equals to square here, we cancel to give what? X plus 1, and everything here can become what? D dx of y multiplied by 1 over x plus 1 whole squared. Then what do I have here? X plus 1. I multiply both sides by what? By dx. So I have d open bracket y over what? X plus 1 all squared equals to what? X plus 1 dx. And from here, what do I have? Integrate both sides. So we have integral of what? D open bracket y over x plus 1 squared is equals to what? Integral of what? X plus 1 dx. I will write. Then from here, what do I have here? Y over what? X plus 1 all squared is equals to what? X squared plus what? Plus x plus what? Plus c. So if my answer like this. So last question on linear. Yes, sir. Here. This one here is from this place. After you have multiplied by integrating factor, d dx of y times integrating factor. This is my integrating factor. After I've multiplied it, this is what I have. The next step will now be what? D dx of what? Y times what? Integrating factor. It's from this step. Should you understand? Okay. Last question. What's the issue? Alpha, waiting stop now. What's the issue? What's the issue? What is having an issue? Right, let's continue. Yes, ma'am. Yes, ma'am. Okay, you see this one here. Don't worry. You see this one. All of them are just part of formulas. This is the format that we wrote on the board. So I'm using this format to solve this equation. Then after this one, I'll look for my p of x, which will be in this format. So my p of x is anything that is beside my y. So what is beside my y here? Minus 2 over what? X plus 1. You see, that's why it's p of x. And my q of x here is anything that is after what? The equal to sign. So what is after my equal to sign here? X plus 1 is parting. And this is the equal to sign. So the one after this sign is what? Q of x. So what is the one after the equal to sign here? X plus 1 is part 3. So it's the same thing as what? Q of x. And from here, I just did follow the format. So the format I just did from there. Okay, let's look at one more question. Okay. Okay. All right, so one more question. One more question. Okay. Let's do for one that looks interesting. I don't want to do the one that looks interesting. Okay, I'll see one that looks interesting. Okay, let's deal with this. Divide dx plus 2xy equals to 2 exponential minus x squared. Yeah, this one is simple, safe. Very simple now. Have you know? Is it not simple? Is it not simple? Eh? My five is too much. I think I got him to do it. There's a good guy. Yeah, it's minus x squared. Now let's start. So what's my p of x here? 2x. What's my q of x? It is what? 2 exponential minus what? X squared. Yes or no? So what's your integrating factor? That's what? Exponential integral what? 2x. Yes or no? And if we integrate 2x, what's your answer here? Exponential x squared. Yes or no? Yes or no now? The next one is that this is equation 1. So you can say that multiply equation 1 by what? Exponential what? X squared. So what do I have here? I have dy dx plus 2xy multiplied by what? Exponential x squared equals to 2 exponential minus x squared multiplied by exponential what? X squared. So what do I have here? Exponential x squared dy dx plus what? 2xy exponential what? X squared equals to, so what do I have here? I have 2 exponential what? Minus x squared plus x squared. Yes or no? Indices. Then everything that gives you what? D dx of what? Y times what? Exponential minus what? Sorry, not minus now. Exponential x squared, which equals to what? 2 exponential what? 0. Yes or no? Then your d dx here, which is the same thing as y exponential x squared, which equals to what? 2. And pick your dx to the other side. You can say that your dx is equals to, you have d open bracket what? Y exponential what? X squared, which is equals to what? 2 dx. And if you integrate both sides, so that's d y exponential what? Minus x squared. Sorry, why am I writing minus x squared like this? This is equals to integration of what? 2 dx. And final answer is what? Y exponential what? X squared is equals to what? 2x plus what? Plus c. That's your answer. So number 4. What is number 4? Bernoulli. As you slow down. Yeah. I want to jump to exam. Now when I was telling you that time, look as if I was joking. So now Bernoulli, then after Bernoulli, look at about 5 examples, then move on to exact. From exact, we continue again. From exact, we continue again. But probably on 215. But also that. See, let me tell you something. Do you know my goal with all of us? Yeah? My goal is that after this 4 days things you are doing, you will not go back to any MTS class confused again. So all right, I'm waiting now, please. I'm waiting. If I don't pay for this one, no. So now Bernoulli, about 5 examples we do, right? Yeah, 5 examples we do. Then from 5 we move on to exact, which is what the simplest so far. I've been now. I think the longest so far that we have done is what? Is homogeneous. Homogeneous is long, very, very long. Because from homogeneous, okay, it should be homogeneous Bernoulli linear. Because in that homogeneous, you have to substitute twice or 3 times. I'm waiting. Are we done? Please let's write fast, please. So now the first thing that we're going to write is that we're going to write out the format. That is how a Bernoulli equation looks like, and how we approach the solvings and all. Are we ready? Let's pick up now. I think we are more than 30 here. Are we ready? Are we ready? Good. Let's continue. So now Bernoulli. So Bernoulli looks like exact, but it's just a little bit different from exact, in the sense that it is written in this format: dy dx plus p of x y, which equals to what? Q of x y to the power of n. Now, if you compare it, you see that the only difference between Bernoulli and exact is that y raised to the power n that it has. I mean, Bernoulli and linear. I don't know why exact is entering my mouth. The y dx, then plus. Let me call this one p. Then I'll give me what? Y minus n. Yes or no? Equals to what? Q of what? Q of x. And the next one here, I can now say that let z equals to what? Y raised to the power what? 1 minus n. Then by differentiating this, what do I have? I have dz dx will give me, what do I have here? 1 minus n. And if I write this, I will have what? Y raised to the power what? Minus n. Yes or no? But don't forget that you are differentiating with respect to what? X. Then from here, after we are done with this, you find out that the only thing that makes this differential equation here, or this particular thing, different from this one is what? 1 minus n. Yes or no? 1 minus n is what makes everything here different from this. I can call this one probably equation 1, and I'll be like multiply equation 1 by what? What is multiply equation 1? 1 by 1 minus n, right? So if I multiply this one by 1 minus n, what do I have? I have what? 1 minus n y raised to the power what? Minus n dy dx plus what? P open bracket 1 minus n y raised to the power what? 1 minus n equals to what? Q open bracket what? 1 minus n. Are we together, please? Yes, sir. Then from here, you find out that everything here and everything here is the same thing. Everything here and everything here is the same thing. Then I can call everything here to be what? Dx, dz, dx. Are we together? Plus. Now everything here, I have p open bracket 1 minus n. And what is y raised to the power of 1 minus n? That's what? Z. Z is equal to what? This will give me 1 minus n multiplied by what? By q. So by this one again, I have reverted my Bernoulli to a what? A linear equation. Out together. From where? From this part here. Okay, do you know that after, do you get what I did here? Now from here, I said that the only thing that makes this one here different from this differentiation is equals to, I'm coming. Ma? From here, you have this. Yes, that is how the format will be. From here, you have this. Then differentiate by this. So this one here will come here, in the sense that, I hope you understand how I got here. I just divided everything by what? Y raised to the power n. Yes, I wrote minus n because this one here will be the same thing as 1 over y raised to the power n. Don't forget, I'm dividing everything by y. She gets good. That's why this one itself is become y minus 1 minus n. And I have qx after I've left this one. I get in it. Then after this one, I now said that let z equal to what? Y to the power of what? 1 minus n. We are just assuming, we let it. If z is equals to this, then I differentiate these two sides. If I differentiate z, I have what? Dz dx. If I differentiate this one, what do I have? The power on top will come to the front. Then y, if I subtract 1 from the power again, what do I have again? I have minus n here. Then don't forget dy dx. You got to manage it like that. Then from here, you will find out that the only thing that makes this one here different from this one is what? 1 minus n. Then multiply everything here by what? 1 minus n. Then you have this. Then you see that this one here and this one here is the same thing. And don't forget that everything here and everything here is the same thing as what? The z dx. Do you understand? Then you cannot substitute. Then p 1 minus 1, then as much as we can have it. We must enter exact today by force by fire. Okay. Let's look at this example. dy dx plus y over x, okay, equals to y squared ln x. We have something like this first. So then from this one here, what do? The first thing that we do is what? Is that we divide, just like the same thing I did here. I have a y to the power of n here. So what do? I divide or multiply everything by what? Y raised to power what? Minus 2. Are we together? Then if I do that, what would I have here? I'll have what? Y raised to power minus 2 dy dx plus what? Y raised to power, or let me better say this as what? 1 over x, y raised to power what? Minus 1 equals to what? Ln x. Are we together? Then just like the same thing I did here, I can say that let z equals to what? Y raised to power what? Minus 1. Then if I differentiate this one here, I have dz dx equals to minus 1 y raised to power what? Minus 2 dy dx. Are we getting it? Then from here, you find out that the only thing that makes this one here different from this one here is what? This minus 1. Happy now? So with this minus 1, let me now say that multiply equation 1 by what? Minus 1. So what do I have here? I have minus 1 minus 2 dy dx minus 1 over x y minus 1 equals to what? Minus ln x. Then you find out that everything here and everything here is the same thing. Then everything here is the same thing as what? Dz dx minus 1 over x. Don't forget that I said that z is equals to what? Y raised to power minus 1. That will give me what? Z equals to what? Minus 1 over what? Ln x. So then from here, then what can I now say? So what is my p of x? My p of x is what? Minus 1 over x, and your q of x here will give you what? Minus ln x. Are we together? Are we together? Then from here, what is my integrating factor? My integrating factor is what? Exponential integral. Exponential integral what? Minus 1 over x dx, which will give me what? Exponential minus ln x. Are we together? Minus ln x. Then this minus can come on top of it. That will give me what? Exponential ln x minus 1. Then your integrating factor here is what? 1 over what? X. So I've gotten my integrating factor here. Alright, so I've gotten my integrating fraction here. So I can call every of this equation here. I call this one equation 1. I can call this one what? Equation what? Equation 2. So I'll continue and say that multiply, what is that? Multiply equation 2 by what? Integrating factor. What's equation 2? I have what? Dz over what? Dx minus 1 over what? Xz. What's my integrating factor here? 1 over x. Then what do I have here? Equals to minus ln x over what? Minus ln x times what? 1 over x. Then opening this bracket, I have 1 over x dz dx minus what? 1 over x squared z equals to minus ln x over what? Over x. Then everything here will give you the same thing as d dx of what? Z multiplying your what? Integrating factor 1 over x, which is equals to minus ln x over what? Over x. So from here, I have d dx, open bracket, z over what? X equals to minus ln x over what? X. Then bring this dx to the other side, and I have d open bracket z over x is equals to minus ln x over what? Over x dx. And from here, I what? Integrate both sides. D open bracket z over x equals to integration of minus ln x over x dx. And how do I integrate this? Please do understand this part. Huh? Now, how do I integrate this? What integration do I use? What integration do I use? Huh? What integration do I use? I use integration by substitution. So from here, I can call this one to be z over x straight up. So for me, I can say that let what? Which one am I using? And let u equals to what? Ln x. Du is equals to what? 1 over x dx. And from here, I can say that x du is equals to what? Dx. And so from here, what do I now have? I can have z over x is equals to integration of minus u over what? X. Multiplied by, what is my dx here? X du. Cancel out, and your answer is z over x is equals to what? Integration minus u du. Z over x is equals to minus u squared over 2 plus what? Plus c. Then don't forget here that your z here was a value. So z equals to minus ln x all squared over 2 plus what? Plus c. I could have left my answer like this, but I cannot, because my question was not given in terms of z. It was given in terms of what? X and y. So what is your z here? Your z was what? What's your z? Y. So for me, I can now have y is my minus 1 over x equals to what? Minus ln x all squared divided by 2 plus what? C. And everything here can still be written as what? 1 over xy equals to minus ln x all squared divided by 2 plus what? C. That'll be my final answer. Let's look at it and next questions, see if we have any. Let's look at it and ask questions if we have any. Let's look at it and ask questions if we have any. I'm waiting now. Yeah. Because there's a d outside in front of it. That integral will cancel the d, personally. It's not the z over x, but the d. She grab. Y dx plus y dx minus y squared x plus y squared x. minus square sec. Alright, so alright. Now this one now you will find out that it's not even obeying the order of Bernoulli at all. I want to be disobedient. So let's punish him for being disobedient. Yes, now. You can't be disobedient to the law. What do you have to do here? They'll bring this one to the other side here. Then what do I have here? The y dx minus what? Y tan x equals to what? Minus y squared sec x. Then from here, divide both sides by what? Y squared. Or minus y squared, better still. What do I have here? I'll have minus y minus 2 dy dx plus y minus 1 tan x equals to what? Sec x. Then from here, let your z equals to what? Y is per minus 1. And here, the z dx is equals to what? Minus y is per minus 2. The square y, sorry, the y dx. Please, are we getting please? So from here, what do I have here? I have everything here, and everything here is the same thing. I can present that as what? The z dx plus, what is your y prime? Y is per minus 1. Z tan x is equals to what? Sec x. Then what is my p here? I said that my p of x here is equals to what? An x, and my q of x here is equals to what? Sec x. So what is my integrating factor? That's exponential integral of what? An x dx. And if you integrate an x, I'm telling the answer now. Exponential minus ln cos x. And this one here can come to the other side. And I have what? Exponential minus 1 with the same thing as what? 1 over what? Cos x. Please let's look at it. If you don't understand, please ask questions. Please, if you don't understand, please what? Ask questions. Feel free, ask. That means you're telling me that everybody understands what I've done. Even collecting motivation. I'm waiting for us to finish writing now. Alright, so from here, I think, so in factor. So what is that one? So I can have the z dx out together. Everything here is being multiplied by 1 over what? Cos x. And that is the same thing as saying you have sec x times 1 over what? Cos x. So let this one enter this place. Don't forget that 1 over cos is what? Is sec. If sec enters here, what do I have here? I have sec x dy dx plus what? Z tan x sec x equals to, this will give me what? Sec squared what? X. Yes or no? Yes or no? Then from here, what do I have? D dx of what? of z multiplied by what? Sec x, which is equals to what? Sec squared x. Then you have d z multiplied by sec x, which is the same thing as saying sec squared x, out there, dx. Then integrating both sides, d z multiplied by sec x equals to what? Integration of what? Sec squared x dx. Then from here, you have what? Z sec x equals to what? If you integrate sec squared, what do you have here? Tan x plus what? C. Then what is your z? What was your z before? Your z was what? Y raised to power minus 1 sec x equals what? Tan x plus what? Plus c. You can do it anyhow you like. So, but this is where I want to stop. Yes, ma'am. How do I get this minus here? Yeah, the thing is that if you integrate tan is sine over cos. And if you differentiate cos, we're supposed to have minus sine. But I have what? Sine in. That minus that I was supposed to have that I did not have, I introduced it. And I introduced my what? Ln. Because if I differentiate down here, I get up. Figure out. Like there's a lot that says if you differentiate down and you get up, it should be ln of down. That's what happened. So cos was supposed to give me minus sign, but there was no minus here. That minus that was missing was what I introduced to my answer. And ln of what? Of course. Figure out. Okay. Exact. Exact. So exact. How do we know exact DE? So exact DE are written in this format: m dx plus n dy equals to 0. That's how they are written. And to test for exactness, you will deal with this partial m partial y was equal to what? Partial n partial x. And solutions or method of solving. You will be having number 1, which is integrate m with respect to x, keeping y as constant. Next one, integrate n with respect to y all terms without x. Number 3, answer 1 plus answer 2 plus the constant. So these are everything that you have to do with exact. As far as exact is concerned, yes? Yes? Yeah. I didn't write it well, but I wrote d dx of z multiplied by sec. Okay, sorry, thank you. Is it? Alright. So now let's talk about exact. As I said earlier on, I said that all exact are written in what? In this form. M dx plus what? N dy. And before you solve any exact differential equation, the first thing you have to do is what? You have to test for what? Exactness. And what does partial m partial y means? It means you want to differentiate m only with respect to what? X. And partial n partial x means you want to differentiate n only with what? Respect to what? X. This one is only with respect to y. This is only with respect to what? X. Then we follow all of these ones. Let's see probably 2 examples if time permits us. But let's see one. That's a very easy one. Okay, let's see this. We have x plus y minus 10 dx. We have this one to be number 1, which is x plus y minus 10 dx. X plus y minus 10 dx plus x minus y minus 2 dy. X minus y minus 2 dy equals to 0. So let's look at this thing, please. So if you look at this thing here, so what do we find out? We find out that at the end of the day here, so what's my m here? My m is what? X plus y minus 10, and my n here is equals what? X minus y minus 2. So first thing I have to do is what? Let's test. So partial m, partial y. So what is partial m, partial y? It means that the only thing you want to differentiate in this equation is what? Y. Any other thing apart from y is a what? Constant. So if I differentiate y here, what do I have? 1. Partial n, partial x. If I differentiate only x here, what do I have here? 1. So you find out that partial m, partial, this partial m, partial y, partial n, partial x is equal to what? They're equal to each other. Are we together? And so from here, now the next thing we have to do is what? We now have to start solving. Now, first solution means that you want to integrate m with respect to what? X. So, but there's a twist to it. Despite the fact that you're integrating m with respect to x, what are you keeping as constant? Y. That means you will treat y the same way as you will treat what? A number. Do you understand what I'm trying to say like that? So from here, what do I have? What is my m? My m is what? X plus y minus 10, everything here is dx. So if I integrate x here, what do I have here? X squared over 2 plus, now y is a constant, and I hope you know that integration of a constant will always have x attached to it. So what will I have here? Xy minus, if I integrate 10, what do I have here? 10x. So I'm done with first solution. I'll get what I'm trying to say like that. Are we getting it, please? What I'm saying is that the same way, you know that if you differentiate 2, what will you have? The same way, what will happen to y? The reason is because y, you are keeping what? Y as what? Constant. Should we get what I'm trying to say like that? Now, the next one, number 2, says that you want to integrate n with respect to what? To y. And to integrate n with respect to y, we are not just integrating all of n. The only thing that concerns you in n that you're integrating is that all terms that does not have what? X is what you want to integrate. So as far as my n is concerned, I will be integrating what? Minus y minus 2 dy. Because I can only integrate all terms without what? Without x. So if I integrate minus y, what do I have here? Minus y squared divided by 2, then minus 2y. Then what's the last step? Last step number 3 says that the answer you have in your first step plus answer you have in what? Second step. Everything added together should give you what? Your constant. So what is answer in your first step here? X squared over 2 plus xy minus 10x. Now plus minus yx over 2 minus what? 2y equals to what? C. And if you open the bracket here, what will you have? You have what? X squared divided by 2 plus xy minus 10x minus y squared over 2 minus 2y equals to what? C. That's my answer. So solving exact differential equation is not a problem. I'll get my answer like that. As far as you can follow these laws. It's very, very easy. Let's come again with the law one more time so that we can master it. What is the law? The law says that first thing that all exact are written in this format. M dx plus what? N dy equals to 0. Then the next thing that you're writing is that for you to work with any exact, you have to test for what? Test for exactness. And there are some scenarios. Are we listening, please? Now there are some scenarios where the questions can be written in terms of dy, in terms of dx and dy. that doesn't mean that all scenarios that you see the x and the y means it is automatically exact. I get it. So before something can be exact, you have to what? Test for exactness. I get what I'm trying to say like that. So if you test for exactness and these two condition holds, then you can follow suit and what? And solve. Please don't forget this part that says that whenever you want to integrate m, you are integrating m with what? Respect to x. And what are you doing to y? You are keeping what? Y as constant. Now on the other part here, you are not only integrating everything in n, you are only integrating all the variables in n that does not have what? X. Do you understand what I'm trying to say like that? Do you understand what I'm trying to say like that? So probably, I think, so now next exact differential equations, and I might be able to teach you a little, just add small knowledge to you about what happens if something is non-exact. How do you solve it? We'll treat that. So let's just plot our map for next class. By that time, we'll be talking about second order differential equations. Then if we have time, we might be able to enter Laplace that same class. If we have time. I said if we have time. We have time. So I wish you all guys best of luck. Thank you very much. And it is a very pleasure to meet you. Thank you. Have a nice day.
Check. Press go. I want to use this. Check. For question. Yeah. Check. Hallelujah. Check. How am I saying hallelujah? This place no be church. Don't increase the music. No, don't increase the music. Check. This speaker now. The speaker is sounding somehow. What am I doing? Check. 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 Whoa. Check. 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 This week I don't know, I beg. Check. 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 One more. This guy. Check. 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 Check.
59 rẹ̀ ọlọ́run 59 lè ẹ bẹ̀rẹ̀ yẹ́sù hello ẹ bá yín sókè díẹ̀ jọ mo bá yín sókè ẹjọ ẹ já bẹ̀rẹ̀ o let's start please okay so now ó ti pọ̀ jù ẹ bá yín sókè báyìí okay wá okay díẹ̀ báyìí wá okay báyìí so MTS 101 ìwé ó ti pọ̀ jù MTS 101 yeah it's okay like this if you can have it like this okay yes so MTS 101 so all right, so I think good afternoon, everybody. So let's talk now about. Are looking at me as if let's talk. So we started. I think the last time we met, we talked about set theory, right? And I've been expecting to see you for a long time ago. I think God has made that prayer. So let's look at MI today. So this day, today we'll be looking at MI by God's grace, and we'll also enter sequences and series too. So are we ready? Yeah, let's start. So MI, mathematical induction. So mathematical induction. So now let's talk about mathematical induction. So one thing I wanted to know about mathematical induction is that mathematical induction is an avenue that allows people to verify formulas. So probably you have a given formula and you want to verify it. The avenue that you can use to verify those formulas is with what? Is with mathematical induction. I get what I'm trying to say like that. I get to me, please. So it means that whenever you have formulas to verify whether they are valid or not valid, this formula is not even limited to mathematics, because the higher you go, the more the need to verify equations. And the only platform that allows for verification of equation is what? Mathematical what? Induction. Do you understand what I'm trying to say like that? So I might not be able to give you the definition word for word as you want it, but I can try my best to give you the general overview of what it looks like. Are we together, please? So now, as I've said again, keep it in your head that if you want to verify formulas in any form, the tool you can use is what? Mathematical induction. I hope we are with our manuals. Okay, good. So we'll look at a lot of questions from the manuals. So let's start. So we've defined it. So at the same time too, so let's now start. Let's start looking at some terms. So let's look at it. Let me say categories. Yeah. Categories. Categories of MI induction. I want to check the categories. Now, the thing is that as far as it is concerned, we have about 3 categories. The first one is the word problem. First one will be the word problems. Now, the second one will be the series. And the third one here would be inequalities. So these are the 3 categories of mathematical inductions that we have. But as far as I'm concerned, and as far as FUTA is concerned, everything that I'll be teaching you will just be based on what? Word problems and series. I guess what I'm trying to say. So probably if you want to know it later, maybe not today, and later again I can teach you personally all the categories on inequalities. I guess what I'm trying to say like that. But so far so good, let's concentrate on what FUTA will give us. Are we getting it? So this is how we do it. We do the normal method, and at the same time we do the shortcut method, which will be very fast. And we start. Okay, good. So with these word problems, let's start with the word problems first. So word problems. Now, this is it. Now, anytime you hear that they want to, or anytime you hear this word, all positive integers, So probably you saw a question, and the question was emphasizing the fact that there's going to be a use of all positive integers. So that means all the numbers you'll be using will be ranging from 1, 2, 3, 4, then up to what? K and what? K plus 1. Please, it is very, very important for you to what? To note that. I guess what I'm trying to say like that. Those are some important keywords that you have to put in your heart. Now, the second one here, apart from all positive integers, will be now all positive even integers. All positive even integers. Now, in even integers, now this time around, what we'll be using? We'll be using numbers like 2, 4, 6, 8. Then instead of you to have your k this time around, you'll be having your 2k, and the same time you're having your what? 2k plus 2. Are we together, please? Are we together? Are we together? Okay, good. So this is another note I wanted to another important thing I wanted to note. And the third one here will now be all positive odd integers. All positive odd integers. Then what will I be using here? I'll be using 1, 3, 5, 7. Then we can move on straight out to using 2k minus 1 and what? 2k plus what? 2k plus 1. Are we together, please? Are we together? Now, these are all the important keywords you have to know first before we start this journey of what? Of MI in word problems. I think we can treat as many examples as we can think of. Now, let's start. And there might be some scenarios again. That reminds me, yeah. There might be some scenarios again where they might not necessarily tell you, or they might not emphasize what family of numbers you have to use. I get what I'm trying to say. So if they are not specifying what family of number you have to use, just go straight and use what? All positive what? Integer. You got what I'm trying to say like that? Okay, good. Now let's look at this example. Probably this should be example 26 or 27 in your manual. So that says that first thing, let's say we want to prove that 5 to the power of n minus 1 is a multiple of what? Of 4. Have you seen this question? Question 20 what? Yeah, just as I said, 26. Now I want to look at this. I want to prove this. That is, that I want to prove that that formula that formula 5n to the power of 1 is what? Is a multiple of 4. And the first thing I have to do here is that try as much as possible to write this formula in form of a polynomial. I can say that f of n equals to 5n minus 1. Are we together? Now, this is how we started. And you know that I said that whenever they give you a question and they did not specify what, and they did not specify what family of number you have to use, what they ask you to use what? All positive integers. So this question did not specify what type of numbers are you going to use. So what are you going to use? All positive integers. So from here, I can now start that when n is equals to what? 1. So what will happen? So here I will have f of 1 equals to 5 raised to the power 1 minus 1. Are we together? And 5 raised to the power 1 is same as 5 minus 1. And f of 1 can be said to give me what? 4. Yes or no? So 4 is also known as what? 4 multiplied by what? By 1. Yes or no? So this one is actually showing that the first answer that I had there was a what? Was a multiple of what? Of 4. I'll get what I'm trying to say, please. Now the second one, next one we are using is what? When n equals to what? Equals to 2. And then you have f of 2 equals to 5 squared minus 1, which will give me 25 minus 1, which is what? 24. And 24 it seems as saying you have 4 open bracket what? Open bracket 6. Now let me pass this important information to you, and it is that whenever you are dealing with MI and you have verified for 1, you have verified for 2, most of your questions you will see will be on CBT. So it is not advisable for you to verify for 3, verify for 4, 5, 6, 7. You understand what I'm trying to say like that? Once you have verified for 1, it's valid. You have verified for 2, is valid. You verified for 3, is also what? So valid. That's what? Continue with your work. I get what I'm trying to say like that. And also, don't prepare for a question that will be invalid. What I say? Don't prepare for a question that will be invalid. FUTA cannot give a question that will not be valid. As long as it is MI, yeah, the question that will give you will be what? Will be 100% what? Valid. You got what I'm trying to say like that. So most of the time, you might necessarily not need to start proving, because even if you are proving, you are wasting time. I get one branch like that. Good. Then from here, I have proved when n equals to 2. The next proof I will have in here is that we'll now start assuming. Now assume n equals to k. Now if I assume that n equals to k, so assuming n equals to k, what do I have? So I can have that f of k with the same thing as 5 to the power of k minus 1 is equals to what? How many m here? 4m. Let me explain the concept of our 4m for you. That means that whatever number of what's it called now? Whatever number or whatever value of k you input inside that formula, at the end of the day, what will you have? You have a what? A multiple of 4. Yes or no? When I put 1, I add a multiple of 4, which is 4. When I put 2, I add a multiple of 4, which is what? 24. When I put in another 4 now, let's say that when n equals to 3, that's 5 raised to the power 3 is 125. 125 minus 1 is what? 124. And if we divide 124, you should have about 31, if I'm correct. So the gap is what? Is increasing day by day. Let's get one apprentice like that. So good. So now that's why here, by the time you have done all of this one, you will later have it. Now you see, this 4m is telling you that irrespective of the number you put there, you can still have what? The answer you still have will be what? A multiple of what? Of 4. Do you understand? Okay, good. And after you've assumed, so this time, this place, this is where some people make mistake a lot. Now, this place, you are free to use anything at your discretion for your k plus 1. You are free to what? Use anything at your discretion for your what? K plus 1. If you feel that 1 will appear, you can use 1. If you see that any letter will appear in your what? In your application, you can what? Use it. I will get one branch like that. So for me, as far as I'm concerned, I'll use 5 to the power of k equals to what? 4m plus what? Plus 1. I'll go to an apprentice like that. I'll go to an apprentice. So from here, I can call this one here. I can call it what? Equation what? Equation 1. And the next one you are going is what? You are going to let n equals to what? K plus 1. You have f k plus 1 equals to, what do I have? So I have 5 to the power of what? K plus 1 minus 1. Are we getting it? So people tend to stop here a lot. Because they'll be like, I can't continue further. I'm going to stop here a lot. So from here, I don't want to stop there. But from here, can we just have it as 5 raised to the power k multiplying 5 raised to the power 1 minus 1? Yes or no? Indices, right? I mean now. Then from there, let's say that now I can now have 5 to the power of k minus 1. I just want to print it like that. And what I'm trying to say is that this one here is 5 to the power of k multiplied by what? 5 minus what? 1. Are we getting it? And from here, I have always 5 to the power of k here. That's what? 4m plus 1 multiplied by 5 minus 1. All together. And everything, if you open this bracket to give us 20m plus 5 minus 1. Abi now. And at the end of the word, I have 20m plus 4. And this is 20m plus 4. What do I have to find? Check. So from here, can I remove 4 from your answer? Yes. 4 absolutely will make 5m plus 1 shrink. I guess my parents say like that. Okay, that's what I've been the best answer for here. You get? So please, it's always very, 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 very important. That is what? Very, very important. Altogether. Now this place, you can just feel free to use any of your words. Any of your law. And by God's grace, you will still get what? The same answer. As long as you follow the words. As long as you follow the principle. Are we together? Are we together? Okay. Alright, let's get another question. Okay. I think there's this popular question in your book that asks you to prove that 5. I'll call the question for people and see it in your notes. 5 clinical. I think it's the last one in your first page. What do I have here? 5 is power 2n plus 3n minus 1 is a multiple of 9. Are we together? Okay, good. So first thing, as I've said, as usual, first thing is what? Look for a way to what? Write it. So from here I can have f of n to give me what? 5 2n plus 3n minus 1. Are we together? Then let's start. When what? N equals to 1, and what do you have? You have f greater than 0 equals to, when n equals to 1, and I want to come, so that will be 5 raised by what? Should be 5 2 1 plus 3 raised by 1 minus 1, and f of 1 will give me 5 squared plus 3 minus 1. Then everything here, 25 plus 3 is what? 28. 28 minus 1 is what? 27. Everything here, give me what? 27. And 27 is as what? 9 multiplied by 3. Abi now. Now the second one, which should be when n is equals to 2. If n equals to 2 here, I have n of 2. It gives me 2 plus, okay, 2 open bracket 2, right? Are we seeing it, please? Okay, good. Now 5 2 open bracket 2 plus what? 3 open bracket 2 minus what? 1. And everything here, what do I have? I have 5 raised by what? 4 plus 9, I don't know, plus 6 minus 1. I think at the end of everything here, 5 raised by 4 is 625 plus 5. At the end of the day, you have what? 630. I mean, no? And 630 is the same as saying, I open bracket what? 70. Yes or no? Okay, good. And from here, so that's the next one. Let's what? Let's assume that what? N is equals to what? K. And putting k here, I have what? 5 2k plus 3k minus 1 equals to 0. And from here, I told you that use any one of your choice, but I will use 5 to the power of 2k. 5 to the power of 2k equals to 1 minus 3k. Are we together, please? I can call this one equation 1. What's equation 2? So the next equation here is let n equals to what? K plus 1. And if n equals to k plus 1, so I have 5 to the power of 2 k plus 1 plus 3 open bracket k plus 1. And from here, what do you have? You have 5 to the power of 2q plus 2 plus 3 as k plus camp. Then from here, okay, sorry. I have 3 here, k plus 1 minus 1, then plus, what is this here? Plus 3, right? Minus 1. Are we together? Okay, good. So from here, what do I now have here? I can break this down to be 5 to the power of 2k multiplied by what? 5 squared plus what? 3k plus what is this? Plus 2. Yes or no? And what is 5 to the power of 2k? I think I substituted that here to be 1 minus 3k. Everything multiplied by 5 squared is what? 25 plus 3k plus what? 2. If I open this bracket, what do I have? I have 25 minus 75k plus, no? 75k plus 25, plus 3k. Are we together? Then 25. Then what's the next one? Plus what? Plus 2. Let's collect like times together. What do I have? 27 minus what? 72k. What? Where? Oh, okay, yeah. Also, yes. Thank you. So this one will give you what? 9m. Then this one now give us what is this now? 9m minus 3k plus 1. Then I think, what would I have to put that in here? Yeah, okay, thank you very much. So this will give me, so I have, open bracket, 9m, 3k plus 1, right? Multiplied by what? 25 plus what? 3k plus 2. If I open the bracket here, what is 25 times 9? I don't want to know. I don't want to know. Times 9m. Do you know why? Because I'll still have to factorize 9 outside again. I'll get one apprentice like that. Then minus, what do I have here? 27k plus what? 25. 3k plus what? Plus 2. So let's, as I said, I don't want to know what this one is. This, yeah, this should be 25. Oh. Okay. $75. Okay. And from here, what do I have? I have 25 times 9m minus 72k plus what? 27. And what's common here? 9. I have what? 25m minus 8k plus 30. And everything here makes it a what? Multiple of 9. Do you understand, please? Do we get, please? Do we get? Okay, let's get another question. There's this popular question that has to do with 5 to the power of 11 something in your manual, if you can get it. That something is a multiple of 11, or I can't remember what multiple of it. I think it's a multiple of 9. I think to the power of 10. Okay, now the next one is what? 5 raised by what? N plus 2 times now they said that this one, we should prove that this one is a what? Is a multiple of 3. And how do I prove multiple of 3? Now the first thing I will do first is that start. Now let me start teaching the shortcut so that I can make the time move faster. And the first thing I want to tell you is that whenever you give equation like this, just know that first of all that equation is what? Is valid. Just not apparently like that. Just know that it's what? Automatically it is what? It is valid. Because it is valid, don't stress yourself by what? By proving n equals to 1 or what? N equals to 2. You're wasting your time like that. Therefore, next case should just be that you should what? Assume n equals to what? K. And if I assume here, what do I have? 5k plus 2 times 11k equals to 0. I be now, not 0 here, 3m. So from here, it cannot be left at your own discretion to make any of them here subject of the formula. So which one should we use? If 5k or 11k? Now let's use 5k. If I have 5k, what do I have? I have 3m minus 2 times 11 raised by what? K. Yes or no? And the next one is that let n is equal to what? K plus 1. And if n equals to k plus 1, so what do I have here? I can have 5 to the power of k plus 1 plus what? 2 times 11 to the power of what? K plus 1. Are we together? And I have what? 5 to the power of k multiplied with then plus 2 times 11. K is the same as k multiplied by 11 raised by 1. Yes or no? And everything I can give. What's my 5 here? My 5 raised by k. And if I go, which is 3m minus 2 times 11 raised by k multiplied by what? 5. Are we together? What do I have here? Plus this one and this one are just numbers. So 2 times 11 should give me what? 22 times what? 11 raised by what? K. I'll get what I'm trying to say, please. I'll get what I'm saying, please. Now what I'm saying is that, you see, 11 is, okay, let me break it down. So for me, you can have 2 times 11 raised by k multiplied by k raised by minus 1. Abi now? And from here, this is 11, this is 2. What can I have here? Let's open this bracket. So I have 15m minus 2 times 11 raised by k. Are we together? Multiplied by 5 plus what do I have here? So that this one and this one are numbers. So 2 times 11 give us what? 22 times 11 raised by what? K. Then from here, I have 15m. Now, minus 2 times 5 give what? Minus 10 times 11 raised by what? K. Plus what? 22 times what? 11 raised by what? K. You find out that 11 raised by K is here. 11 raised by K is here. Then what do I have? I have 15m minus plus 12 times what? 11 raised by K. Yes or no? Yes or no, please? You get? Do we get, please? And so from here, if I move this one upwards, moving this one upwards, what do I have? So I have 15m plus 12 times 11 raised by what? K. Let's remove 3. So if I remove 3 here, what do I have here? 5m plus what? 4 times 11 raised by what? K. That will be the final answer. I'll go to my friendship, please. Don't get. You cannot see this, please. Can you see this, please? And what do I have here? I have 15m plus what? 12 times 11 raised by K. That's what I will have there. Then if I factor out 3, what do I have here? 5m plus what? 4 times 11 raised by K. I'll get to the friendship, please. Who you are? Who you are? Okay, good. Now, any other questions that we have from our manuals that we can solve? Sir? Yeah, we are still coming there. We are still coming there. Yeah, I'm listening now. Can you hear you? One over 1.2, then plus 1 over 1. Okay, I'm still coming. We are going there. That will be the series. But do you have any more problems again that we have to solve? Oh yeah. That's a series. We deal with series, but let's deal with what problems now. Do you have any more problems question that we can solve that we have not solved? We don't have again, Abby. Okay. 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 Give me one. I think that one is more of more explanatory. Okay, let's see. You said if I heard the question well, I said I should prove. Now, if you notice now, we're not given whether it's a multiple of any number or not. So how do we verify? Yeah. Yes. Okay. No, because 11 raised to the power k and 5 are completely two different things. They are two complete different things. I get one branch like that. So the only condition where both of them can multiply each other is if this one is 11 raised to the power k and also this one is what? To the power of k. I get one branch like that. But as due to the fact that they are different, no, I can't multiply it. Do you understand? Yeah, just ignore it. I didn't really necessarily ignore it now. This 5 here, whatever I use this 5 here, I use this 5 to multiply the ordinary number that was here. Not with the power of k. You're gonna branch it like that. Okay, another thing. That question we're talking about is more of like proving and solving. We didn't have, it's not clear enough. Okay, let's do one more. But I think I can still come up with one question. But I tell me that all the questions you know is what we have exhausted. Yes, what of the one that has to do with n equals to q minus 1 n plus 1? I was manual, give me the manual. This one that you want to verify now, 7 to the power of 2n plus 1 is divisible by 8. This is 1. That's 1. Then we'll move on to the series part now. Okay, so working with this one, as I said earlier, by 8. So from here, as I said earlier on, that in this time around, you don't literally need to what to prove when n equals to k, when it equals to what when n equals to 1 or 2. They are actually always valid. Okay. Now, so the only thing we have to prove here is what we have to prove for when n is equals to what. Okay, so let's start. Assume n equals to what? K. When I put k inside this formula, what do I have? I have 7 2k plus 1 equals to what? 8m. Yes or no? And from here, what do I have? I have 7 2k plus 1 equals to what? 8m minus 1. And from this part here, which one do I want to use? I think I've used what I want to use. I can call this one your equation what? Equation 1. And the next one is that let n equals to what? K plus 1. Go to like that. Are we getting it, please? Are we getting it, please? Okay, good. So from here, so put it inside that formula. What do I have? I have 7 2 bracket k plus 1 plus 1. Are we getting this, please? Everything I should not give me 7 2k plus 2 plus what? Plus 1 plus what? Plus 1. Now from here, I'm coming right on the other part. Okay. So from there, let me write that question back. So what will I have? I will have what is that? 7 raised to the power what? 2k plus 1 plus 1. Yes or no? Happy now? This is what I will have. So from this particular point here, this one here, I can write it to give you 7 2k plus 1 plus 2 plus 1. Yes or no? Then I can write this one as what? 7 to the power 2k plus 1 multiplied by 7 squared plus what? Plus 1. Yes or no? So from here, don't forget, we already made this one the subject of the formula. So what is that formula there? I did that to be what? As what? 8m minus 1. So we have here to be 8m minus 1 multiplied by, what is 7 squared here? 49 plus 1. So what do I have here? I have 49 times 8 is 392m minus 49 plus 1. 392m minus 48. And for me, what is common here? 8. If I remove 8 from this one, what do I have here? 49 minus what? Minus 6. That will be a what? Your final answer. This one is m. How to get that, please? How to get that, please? So these are all the things you can have on one problem. So you can just feel free to work around them. And I told you that anytime you see a problem, don't stress yourself by what? By going through when n equals to 1, or when n equals to 2, or when n equals to 3. I get my apprentice like that. Just know already that the question that they will give you will be 100% valid. You can just start by saying, assuming n equals to k, and next one is that you assume that s equals to cos k plus 1. Yes? No. You will not arrive at the same answer, but the answer you will arrive at will also be a multiple of 3. You understand? You will not necessarily arrive at the same answer at all. You can't even. But then at the end of the day, you find out that whatever answer you use, you will still be able to factorize what? You'll be factorize 3 from it. Yeah, there will be options. That's why it's more reliable. Now, there are some kind of questions you will see. For example, this type of questions here, this one here that I think that has a lot of choices that you can use as your subject formula might not be common. I don't know, I can't say. But the thing is that I will just try and tell you that use the fastest one possible. I think, for example, now I want to use 11 raised power k here now as my subject formula. I hope not to stress me a lot. Will it not? It will stress me a lot and to take my time. So you're gonna manage it like that. So just probably know the one that you have known for now and let's just stick to it. She gets. Okay, good. Are we done writing, please? Okay, let's continue. Then we'll look at the series. Look at the series type now. Another series type, we'll do probably 3 or 4 examples. Then we'll do the shortcut and we'll move on. Is that okay? Okay. I'm waiting. Ready? Huh? I'm ready. Eh? Okay, let's go. Now, series. How to clean this part? Okay, let me come here. Okay, this side. Now, I will take it down now. So now, series. Okay, I think there's this one that inside your notes that I asked you to prove. I don't know if this is there. You add something like this: 1 plus 2 plus 3 plus 4 plus dot 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 plus n equals to n of bracket n minus 1 over 2. Yes or no? Is this the exact same question? Are you sure? Let me check, please. This type of question. Okay, it's n plus 1. Good. N plus 1. Now, the thing is I want to verify this. So, as I've said, I'll teach you the normal method and at the same time I'll teach you the what? Shortcut. Because your test is next 2 weeks. I'm not sure. But at least you should have, Next week. Is the timetable out? Wow. So now let's look at this. So that means probably you need shortcuts more. You've passed MI in class now. Okay, good. Let's play with shortcuts then. Now, whenever you have something like this, now the thing is that don't focus your attention more on what is on this side here. Don't focus your attention. Delete this side here. I get what I'm trying to say like that. Delete it. So from what you have deleted, what do I have next? I have this one next, which is what? N open bracket what? N plus 1 divided by what? Divided by 2. Are you getting it? Then inside this part here, put n, put n is equals to what? K plus 1. So I put n equals to k plus 1. So what do I have here? I have k plus 1 plus 1 over 2. And final answer here is what? K plus 1 over what? K plus 2 divided by what? 2. That's your final answer. You go and print it like that. So that will be your final answer. So whenever you have something that has to do with series, don't stress yourself by start to prove when n equals to 1, when n equals to 2, stuff like that. And mind you, the paper they will give yourself will not even be enough to allow the provings. So you get an apprentice, you have to be fast and smart. Do you get what I've done here, please? So please, so just know that whenever you are dealing with you are dealing with something like this, you don't focus on whatever is here. The only business you have is what is on this side here. And from what is on this side here, just input your what? N equals to k plus 1 inside, and you're done. Now, okay, another one, I don't know, there's this thing that looks like this in your note. R equals to 1 to n of r squared, which is equals to n over 6, I don't know, something like this. Yeah? Have you seen the question? Yeah, call. Okay, so for me, r squared equals to, what do I have? Okay, it's n squared. R cube, whatever, just call something for me, please. That looks like something like this. N squared, n plus 1 over 4. This is for cube, Abby. Now, as far as for cube, as I told you, although this one here has its meaning, I can break it down. But we are not concerned about it, right? We're just concerned about getting the answer. And the only way we can get the answer is to what? Isolate all of this part and deal with what? And that part. So for me, what do I have? N squared, n plus 1 all squared, divided by what? 4. And for me, what is n squared here? Don't forget, n is what? K plus 1. I have k plus 1 all squared. K plus what? 1 plus 1 all squared, divided by 4. And the next thing I'll see is k plus 1 all squared, k plus 2 all squared, divided by what? 4. Do you understand? That will be your final answer. Please note it. Yes, sir. Expatiate more. You can if you want to, but your answer will be left in the most simplified state. I think this one is even more simplified. If I expand it, create a problem. I don't want to create this problem. If you have questions, please ask so that we can move. Any other questions? All right. I want me to break down the other side. Okay. All right. The meaning of this thing here means sum of all numbers starting from 1 to n following this rule. Let me repeat it again. This thing means that sum of all numbers starting from 1 and ending at n that follows what? This rule. Let me repeat again. Sum of what? All numbers starting from what? 1 ending at what? N that followed what? These rules. From here, if I want to write it now, this one here, I have 1. I'll first put 1 inside this rule, which will be what? 1 cube. Don't forget, is what? Sum of all numbers from 1 to n. And after 1, what will be the next number? 2. Put 2 inside this formula again. 2 cube. And after 2, what's the formula again? 3 cube. Then 4 cube. Then you can go on and on and on and on like that till you get to the last part, which is what? N cube. I get to print it like that. So that is how this one here can be expanded. Do you get? Do we get? So is there any other question on MI? I feel like we can handle MI now. Where is number 22? Let me see it. Number 22. I think we did one. This is okay. We did only the square. Okay, let's do it. Number 22, as you've said. So, number, what is that? I mean 19, what is in 19? Yeah, that fractional power that you're talking about, number 19, is not correct. It's not correct. Yeah, it's not correct, so don't bother yourself about it. Eh? Yeah, if you have another one, I would love to do it with you. Number 33, yes, number 33 is sweet, it's interesting, but it's long. And with time, I want to do it. Are you ready? Okay. Don't say I did not want you. Let's start. Wait, have you done trigonometry? No. Don't worry. Leave number 33. If I teach you trigonometry, you will do it. If I teach you trigonometry, you will do it. Questions like number 33 are not meant to come out in your exam. I can't even see it. So let me talk about question 32 that someone spoke about, which is r equals to 1 of n r squared equals to n over 6 open bracket n plus 1, which is what? 2n plus what? Plus 1. should I interpret it or should I just tell you the answer straight up? Which one? Interpret. Okay, as I've told you here that what does this formula mean? The formula means that sum of all numbers from 1 to n that follows what? This formula. So let's start. So that will give you what? 1 squared plus what? 2 squared plus 3 squared plus 4 squared, on and on and on like that till you get to what? N squared, and everything is equal to what? N over 6, n plus 1, 2n plus what? Plus 1. So from there, as I told you that if you want to solve this, that you don't have any business to do with what? With this first part here. Since you are not writing it down, you have passed this place. I've given you assignment past this place, so you have to be very, very fast whenever you see something like this. The only thing you have to do is what? Just write this one out, which is n divided by 6, n plus 1, and what? 2n plus 1. And inside this formula, put what? Let n equals to what? K plus 1. So if I do that here, what do I have? I have k plus 1 divided by 6, open brackets, okay. Then you have what? K plus 1 over 6. And this is what? K plus 2 plus 2k plus 2 plus 1. Yes or no? And at the final, and you have k plus 1 over 6, then k plus 2, and there you have what? 2k plus what? 3. And this is your what? Your final answer. We're going to approach it like that. So please take note of it. That whenever you can use that trick whenever you're dealing with what? Whenever you're dealing with just talking now. You can use this trick whenever you're dealing with what? With series. I will try to like that. So whenever you're dealing with word problems, and they ask you to probably use word problems, what do you do? Just go straight to what? Your k and your what? And your k plus 1. Yeah, if it's theory, then it's okay for you to go to the length. From probably k equals to 1, k equals to 2, k equals to 3, as many as the number of variables you can want to prove. You can go through it. Any other questions again before we move? Question number 19. Page 19. Page 19, number 7. Away. And that's in another one. I'm still coming to sequence and series. Okay, we want to break that one down. Okay, let's see what this one looks like. So you had a summation of k equals to 1 to 6, open bracket, 3k minus 2. So as I told you now, it's still the same thing as what we have here. But the only difference is that this one here is the sum of all numbers from 1 to 6 inputted in this what? In this formula. So what this one will mean is this. It will mean 3 open bracket 1 minus 2 plus 3 open bracket what? 2 minus 2 plus 3 open bracket 3 minus 2 plus 3 open bracket 4 minus 2 plus 3 open bracket 5 minus 2 plus 3 open bracket what? 6 minus 2, which is where they ask you to stop. I get to know apparently like that. So that just like the same way I did this one, the same way I'm going to do this one. Then from here, if you open your bracket, what do I have? 3 times 1 is what? 3. Minus 2 is what? 1. Plus 3 times 2 is what? 6. 6 minus 2 is what? 4. Plus 3 times 3 is what? 9. 9 minus 2 is what? 7. Plus the next one, 3 times 4 is what? 12. 12 minus 2 is what? 10. Plus the next one, 3 times 5 is what? 15. Minus 2 is what? 13, right? Then if I will guess, the next one will be what? 16. I get one apparently like that. So if you add up all of this one, the answer you get will be the answer for this. The 1 plus 4 is what? 5. 5 plus 7 is what? 12. 12 plus 10 is 22. 22 plus this one is what? 35 plus 16 should give me 60. 35 plus 16 should give me 51. The final answer. You understand apparently like that. So that's how you would deal with the second part too. Are we together? Any other questions again? Now, because I want to enter sequence and series straight up. So any other questions on MI? On MI? Okay. Of the numbers. Okay, all the questions on MI. Other questions in 25, Abi? Okay. Let's cut it together. So you had something that looks like this. Summation of r equals to 1. You are stopping at 9. And you have what? R over what? R factorial. I told you that this thing here just means that find the sum of all these things inside what? This formula. From 1 to what? To what is on top. What would this one give you? What is my R starting with? 1 over what? 1 factorial. Then the next one is what? 2 over what? 2 factorial plus what? 3 over 3 factorial. 4 over what? 4 factorial. Like that until you get to what? 9 over what? 9 factorial. Then you can add them together. 1 over 1 factorial is 1, plus 2 over 2 factorial is 4, 3 over 3 factorial is 6. And that means if they ask you without perform the addition, that means whatever they ask you to do, this is what they ask you to do. And this is your final answer. Without perform the addition, that's what they ask you to do. I'll go to what I'm trying to say like that. And the next one, you did not get. This thing means sum of any number from 1 to n inside, putting inside this what? This formula. So what is my first number starting from? 1. If I put 1 inside this formula, what will I have? 1 over what? 1 factorial. Then after 1, what is the next number again? After 2, what is the next number again? You continue like that, like that, like that, like that until you get to what? Until you get to the number on top. What is the number on top here? 9. And they ask you not to perform the what? The addition. You can just what? Leave your answer like this, straight up. Now to perform the addition, are you with calculator? So if I know with calculator, I can't perform this addition in my head, because this way it should be 1 over 1 factorial is 1, 2 over 2 factorial is 2, 3 over 3 factorial is 6, 4 over 4 factorial should be 24, plus 5 over 5 factorial should be, I think, is it 60 and 120? I think 120. 6 over 6 factorial, I think that should be 720. 7 over 7 factorial, which is 7 and 4, that's 4. I don't know, can plus dot 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 dot. So this one here, so if you want to break it down, this should give you 1 plus, what is this? 1 plus 3 over 2 is what? 0.5, right? Plus, or better still, let's do it in fraction. 1 over 2 plus 1 over what? 6 plus 1 over what? 24, Abi? Plus 1 over what? 120 plus, continue like that. You got to say like that. Do you get it? So if you add up all of this one together, the answer you get will be the answer here from this place. I'll get what I'm saying, please. Okay, good. Now for the next one here, which is summation r is equals to 1 and 8. Sorry, it's not infinity. It's 8. And in this 8, you have minus 1 raised to the power r, 3 raised to the power 3 minus r. As usual, sum of all numbers from 1. From 1 to what? To 8. Substituted inside what? This value. What would this one now be? It will be what? Minus 1 raised to the power what? 1 to 8. Substituted inside what? This formula. Are you getting it? Does this one? So where am I starting this one from? What number am I starting this one from? 0. What number am I eliminating? 6. So if I put all of those that, what do I have here? I have, are you getting it? Then plus, are you getting it? The after 1, what is the next one? After number 2. 2 minus 2 over what? 1 all squared divided by what? 2 factorial. Then you can move on like that, like that, like that until you get to the last part, which is what? The sum. Do we get? Okay, good. So that's that about that. I don't know. Personally, I wish I knew. I met it too like that. My master teacher told me. I don't know why 0 factorial is 1. If I knew, I'll tell you. Huh? Ma? Yes, the thing is, I would rather teach you important things than to waste time and teach you something that will be long. At the end of the day, you will not use. Whatever that sign, whatever that is there, you can close your eyes to it. Yes. You don't know, the thing is that you don't know how deep it is. It is me that can see it from inside. Because I've done it before. And I know how long it is before I can get the answer. Yeah. So that's why I don't want you to waste your time on number 33 at all. Just close your eyes to it. Don't say you did not see it. Now another one again. Another one and MI. Question 20. Yeah, question 20 is inequalities. As I said, for this classic, I will personally not be teaching inequalities. See, let me say some things to you that, although there are a lot of things you feel you will learn, or you feel you want to learn, or you have to learn, but the thing is that there are some times that you will learn some stuff that you might probably hate yourself regretting that you learn it. I guess what I'm trying to say like that. So it is good to bother yourself with things you will need than the things you don't really need. I just feel like if you should know. You got on branch like that. Are you getting me? Okay, good. So that's why all of this thing that is here. It's not that I can't help you out with it, but I feel that why waste your precious time on something you will not use? Let's continue. Shall we? Shall we? Shall we? Sequence and series, shall we? All right. If you have the question, bring it so that we can solve it. Yeah, I think when I started this class, I gave you some list of word numbers to use. And whenever you have all the numbers, what are you supposed to use? 1, 2, 3, use your K and use your what? K plus 1. Then whenever you have odd numbers, I think I listed it here now. When you have odd numbers, you are supposed to use what? 1, 3, 5, 7, what else again? 2K minus 1 and what? 2K plus 1. So I ask you to pick. So you get, I've listed it here already. Do you get? Another person again. So I believe that by now, if you see any questions on Emma, you are good to go with it. Yes or no now? Aha. Yes, the question, sir. Question. Can you just say the number? No.
It's for my notes, sir.
It's from your notes. Okay, I'm listening, sir.
Use the principle of MI to prove that 1 over 1.2.
Okay. What will be the end of that question, please? I just want to know the end.
N over n plus 1.
Okay, now this time is n over n plus 1. Okay. Yes. I think that one will be 1 over 1.2 plus 1 over 2.3 plus 1 over 3.4, blah, 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 plus 1 over n plus 1 equals to what? What do you have here? N over what? N plus 1. Okay, I don't know. According to the question, it was 1 over n that was here. But I told you that whenever you are dealing with what? Series, you don't have business to do with this one here. The only thing you are dealing with is what? This one, which is what? N over what? N plus 1. Now, after I've gotten that, what are you putting inside here? K plus 1. So if I put K plus 1 inside this answer, what do I have here? K plus 1 divided by what? K plus 1 plus 1, which is what? K plus 1 over what? K plus 2. Am I done? You can now? Yes, sir.
There is a question from my notes. Prove that n squared plus 6n plus 2 is a multiple of 9 for all positive integers.
N squared plus 6n plus 2
is a multiple of 9.
Multiple of 9. Okay.
For all positive integers.
For all positive integers. All right. You guys shall want to sleep on this MI. Okay, no problem. I'll sleep with you too. So from here, since they said that it's a multiple of m, I cannot waste my time proving I will assume that point 1 is correct and point 2 is correct. Assuming. So now, let me just move straight to, let's assume that n is equals to what? K. Then I have what? K squared plus 6k plus 2 equals to what? 9m. At my discretion, I want to use k squared. So what do I have here? Take everything to the other side. 9m minus 6k minus 2. Are we together? Then so from here, let me because I don't want to waste that. Okay, I'll stick and clean the whole board now. Now from here, the next one is what? Let n equals to what? K plus 1. Then what do I have here? K plus 1 all squared plus 6 open bracket what? K plus 1 plus what? 2. Now this one here, if we expand this one, what will I have? K squared plus 2k plus 1. Yes or no? Then, plus what do I have here? 6k plus 6 equals, plus 2. Then, so from here, I can, let me collect like terms together first. So I have k squared plus 2k plus 6k will give me what? 8k. 1 plus 6 is what? 7 plus 2 is what? 9. What is your k squared here? Your k squared is what? 9m minus 6k minus 2. Now, plus what? 8k plus 9. Okay, so from here you have what? 9m, 9m. Now, minus 6 here, plus this will give up plus 2k, then plus 7, good. Now? But now the question, yes? Is there any question from here? Okay, good. Now, but the question here is now telling us that we should show that it's a multiple of 9. I think you have done it and you have verified that it is valid for 1, 2. Is it valid for 1 and 2? Okay, good. So from here, if you take away 9 from this one, what would I have left? Removing 9 here, what would I have left? I'll have what? M. I go together. Plus this time around, it's not, let me tell you, probably you don't know before, but now you know. It's not the time that they ask you to find factor that you must have, that 9 must go inside that thing without giving any remainder. It's not all things, it's not all times that it happens. So for example here, the question already specified that this one here is a what? Is a multiple of 9. I have verified that it is true for what? 1, 2. I get what I'm trying to say like that. So from here, I can find a way to manipulate this answer and say that I can have m plus 2 over 9k plus 7 over what? Over 9. Because at the end of the day, if this 9 multiplies everything that I have here, I'll still come back to this question that I have here. Do you understand what I'm trying to say like that? So it is not all the time that you have to prove that by the time you factorize, that everything you're factorizing will give you everything, like it should just give you like, where is it safe? Did we do anyone? Okay, we didn't. I'll just give you your answer, sekwe. You get what I'm trying to say like that? It's not the time. As far as the question I've said is already a multiple of 9, just find a way around it to make sure they know that it's also a what? Multiple of 9. Do we get that? Any other questions before we move? Any other questions? All right, sir. Even as I'm, let me see the stuff you are using. That'd be cool. All the proof that even numbers are even and odd numbers are odd. Okay, how do we articulate that? How do we articulate that? Okay, what are type of even numbers we have? The category of even numbers we have: 2, 4. 2, 4, 6. And before you can say that even numbers are even, why are they even? Even numbers are even because any number that they divide will have no remainder. Okay, so that's another one there. So here we have 8. This is set of even numbers that these ones are even because if they divide any number, I will not have any remainder. let's deal with this question later. You can give me later, after. So let's deal with it. Later. Any other questions to talk about? No other ones. No other ones. No other ones. Thank you very much. No. Then we'll talk about real sequences and series. Real sequences and series. So I don't think I would need this. Sorry? Give me. Okay. I don't think I will need this. No, I'm not taking questions from you. No. So sequences and series. Okay, let's start. Let's define what sequences are, what series are. Just look at some definitions, look at some examples, and we'll move on. So what are sequences? Let's start from there. Definitions. So what do we know as sequence? Sequence here is what? Is known as what? So we want to define what a sequence is. So you guys want to write. Now a sequence is a group of numbers that follow a certain pattern. Yes. Yeah. Sequence is a group of numbers that follow a what? A certain pattern. Now for it to be known as a sequence, the thing is that that sequence must also follow what? Follow a pattern. For example, everything that, for example here, let's say I have 1, 2, 3, 4, 5, 6. This is, I can call this a sequence. Why would I call this a sequence? Because I said that a sequence is a group of numbers that follow a particular pattern. That's what I said. So I was just giving an example that this one here is a sequence. Now why is it a sequence? It's a sequence because it follows the pattern. And what's the pattern? There's an addition of 1 to each term. Yes or no? Good. So as long as it follows a particular kind of pattern, it can be known as a what? As a sequence. Another example of a sequence, probably you have 2, 4, 6, 8, 10. Now what is the pattern? What is the pattern of this one? Addition of what? 2, 2, 2, and what? And 2. I got to trying to say like that. Or probably you are having, let me see, 1 squared, no, don't let me use 1 squared, 1, 2, 4, 8, 16, 32, and whole. Now, what sequence does this one follow? Multiplication of what? Of 2. I get what I'm trying to say like that. So, a sequence is any number or group of numbers that follow what? A particular pattern. Do you understand what I'm trying to say like that? So now, okay, I'm not going in depth to teach you how to probably find patterns. I get what I'm trying to say like that. I'm not teaching you how to find the patterns to a sequence. But let's just have the idea of what a sequence is. Now the other one here is series. Now what does a series look like? Now while a sequence is a group of number that follow a pattern, now a sequence is what? Addition of what? Of numbers in a certain pattern. That's what series is. I repeat, series is what? Addition of what? Numbers in a what? In a certain pattern. For example, whatever we did here, you find out that here, what did I have? I hope you know that this point that is here is not ordinary point, but it's what? Multiplication. So this one, like this point here, which is 1 over 1 times 2 plus 1 over what? 2 times 3. If you find out that at least in this multiplication here, there's a what? There's a sequence. I mean, there's a kind of pattern that it follows. But this one is different from sequence in the sense that series is what? Adding up. I get what I'm trying to say like that. Sequence does not add up. But series does what? Series add ups. For example, if you have this thing that they gave you, 1 squared plus what? 2 squared plus 3 squared plus dot dot dot. If you notice that this one is a what? Is a sequence. And what is, it has a pattern. And what is the pattern? The pattern is what? Squaring of what? Of numbers. But the difference here is that this one here is not a sequence in the sense that I am adding the terms to each other consecutively. you understand what I'm trying to say like that? So this is what this is what the series is. No, n squared. What do they say that this one will give you at the end of the day? I think squared should give you n over 6, and that's n plus 1 and 2n plus 1. At the end of the day, they say that if you add up all of this one here, you have a formula that will be like this. I get what I'm trying to say like that. That is not where I'm actually going, but I just want to explain the definition of what a sequence is and what a series is. Do you understand? And another thing is that you can form a sequence from a series. Do you know what I'm trying to say like that? You can form a sequence from a series. Then how do you do that? You just simply remove and you deduct you remove your addition signs in between. So for example, if I want to make this one move from a series to a sequence, what will it be? I can write it as 1, 4, 9, what? 16, 25, like that. I just brought this one out from what? From a series. Do you get what I'm trying to say like that? Do you understand? Okay, good. So there are different kind of series and different kind of sequence that we have. But as far as we are concerned for your educational purpose and learning, I'll be based on the two basic ones you know, which is what? The arithmetic sequence and series, and the what? Geometric what? Sequence and series. And as I've said, there are more sequence and series. There are a lot of, but as far as this school is concerned, which is what I'm helping you, I'll just teach you basically on what you need to what you need to know. Are we together? Okay, good. So can I clean this part? Okay. So let's start picking them one by one. So based on the ones you have in school, let's start picking them, which is arithmetic sequence. Arithmetic sequence, or what you will call your arithmetic progression. You have the two, arithmetic sequence, or what you call your arithmetic progression. So now the general formula here is given as Tn is equals to a plus n minus 1d, where your Tn here is either your last term or your nth term. Your a here is your what? First term, and your n is times if they ask you of your first time. That is why this is your first time here, is also goes to A. Yes, ma'am. Sequence and progression are the same thing, but sequence and series are different. I think I just highlighted the difference between sequence and series. I'll be now. But progression and sequence are still the same thing. She get okay. Then also here you can have T2. So if I have T2, what do I have here? A plus 2 minus 1D. And I went together. And so from here So what would this have? I would have what? A plus what? 1d. And your second term will give you what? A plus what? A plus d. Now what will happen if you want to complete your third term? The T3 down should be what? A plus what? 3 minus 1d. And your T3 is what? A plus what? 2d. So I think we can, I'm trying to get a progression from it so that we can, we can be able to complete any terms that we have. So if T3 is like this, can you guess what T4 will be? T4 will be what? A plus what? 3d based on this formula. Then what will your T9 be? How about A plus what? 8d. Then what will your T38 be? How about A plus what? 29d. So whatever that I've done here is an example of That's if. Let's build foundation with questions first. Let's build foundation with questions first because I am manual. Okay, so let's take down worked examples. All right, let's write. The seventh term of an arithmetic progression is given as the seventh term of an arithmetic progression is given as the seventh term of an arithmetic progression is given as out there is given as minus 11 if the first term is 2. If the first term is 2, what is the common difference? Let's start building foundations gradually. I would say that, let me repeat, the seventh term of an arithmetic progression is what? Minus 11. If the first term is what? Is 2. The question is what? What is the what? What is the what? Common difference. So let's start with that. So from that, so let's start. So what did they ask you to find? They talked about what? T what? T7. I'll get to what I'm trying to say like, so if I want to compute a formula for T7 is the same thing as what? A plus what? 6D. Are we together? Let's say that I have A plus 6D here. And the question is now telling me that, what is my T7? All of this one is equals to what? Minus 11. Yes or no? And at the same time, what is my, I was given a first term. And what is my first term there? My first term is 2. So if I put my 6D equals to what? Minus 11 minus 2. And 6D is equals to what? Minus 13. So D here will give me what? Minus 13 divided by what? 6. Look at that piece. Now let's start taking it step by step. One step at a time. Okay, the next one. Another question. Okay. What will be the nth term of an AP? What will be the nth term of an AP? What will be the nth term of an AP? What will be the nth term of an AP if it has a common difference of, what will be the nth term of an AP if it has a common difference of, what will be the nth term of an AP if it has a common difference of 1? If it has a common difference of what? Of 1. and its first term is 0. And its first term is what? 0. Are we together? Now the question is asking us that what would be the nth term of what? Of an AP if that's a what? Common difference of what? 1 and its first term is what? 0. Okay. I think let me do that here. Now first thing I wanted to know is that whenever you're talking about AP, what is the general formula of the nth term of an AP? Tn is equals to what? A plus n minus 1d. Are we together? Then so from here, the question asks me to find nth term, given that what is my A? My A is 0, and my common difference here is what? Is 1. I'll go to an parenthesis like that. Then from here, if I substitute A equals to 0 and D equals to 1 inside this space, what will I have? I'll have Tn is equals to what? 0 plus what? N minus 1 multiplied by D. Sorry, not D now, multiplied by what? 1. And the end of that, I can have Tn is equals to what? N minus what? N minus 1. So this will be my what? My nth term. Do we understand, please? Do we understand, please? Okay, you're not seeing it. Sorry. Sorry. Can I see it like this? Eh? Sorry. You should have talked since morning now. Another question. Another question. Okay. Yeah, I'm still coming there. I'm still coming there. I'm still coming there. I want to build this stage by stage. I don't want to jump. Okay, are you done writing? Let's take another question. Now, given the sequence, are we there? Given the sequence 4, given the sequence 4, given the sequence 4, 2, 0, minus 2, dot, compute the common difference. Number 1. The nth term of the AP, or the nth term of the sequence. I've said AP already. The nth term of the sequence instead. The nth term of the sequence and the 18th term of the sequence. Let's look at that question. Okay, so let me have the sequence that I called. I had what? 4, 2, 0, minus 2. Are we together? Dot. Now, first thing that the equation asks us to find is what? Is what? Compute the what? Common difference. And how do I get common difference? So I can say that this is my first term, this is my what? Second term, this is my what? Third term, this is my what? Fourth term. And I think I told you that the common difference here is the same thing as what? T2 minus what? T1, or T3 minus what? T2, or T4 minus what? T3. Your common difference here, what is this? Is first, second, third, and what? And fourth. So let's deal with it. So what's your 2? So I have 2 minus 4, which is equals to what? 0 minus 2, which is equals to what? Minus 2 minus what? 0. And at the end of the day, your common difference is what? Minus 2. Are we together? Now my common difference is what? Is minus 2. Now the next one, what's the next question that I asked you to find? The nth term. Now if my common difference is minus 2 and my A here is what? Is 4. Then I have to put these two formula into what? My Tn. So I can say my Tn is equals to what? A plus what? N minus 1 D. So I don't know what my Tn will look like, but I know that my Tn will follow. What's my A here? 4 plus n minus 1. And what is the d here? Minus 2. Opening the bracket here, I have 4 minus 2n plus 2. And at the end of the day, I have my tn to be what? 6 minus what? 2n. This should be your what? This should be my what? General term. So let's check if this general term is correct. What will happen if n is equals to 0? If n is equals to 1 here, what will happen? What will be my answer if n equals to 1 here? Correct, right? If n is equals to 2, what will I have? Correct. If n equals to 3, what will I have? Are we getting it correct? Which is my third term. And the fourth term, if n is equals to 4, what do I have here? Minus 2. So I can say that with this is my nth theorem, this is my nth term is what? Is valid. So now using this nth term, the question asks me to calculate what? The 18th term. Yes or no? So let's look for the 18th term. So 18th term will be what? T18. And that means that anywhere you see n, you substitute with what? With 18. So what do I have? I have 6 minus 2 open bracket what? 18. And at the same time I have 6 minus what? 36. So the 18th term will be what? Minus what? 30. Do you understand what I'm trying to say like that? Okay, another question. Okay, another question. Given that the third term of an AP, okay, you're still writing. Okay, write fast then. Are we done? Okay, good. You'll have to talk when you're done now. Now, given that the third term of an arithmetic progression is, given that the third term of an arithmetic progression is, given that the third term of an arithmetic progression is, given that the third term of an arithmetic progression is 20. And its eighth term is 35. Find the first term, comma, common difference, comma, nth term of the AP, comma, and 22nd term. I hope you all got that. Okay, you find the first term, comma, common difference, comma, nth term, comma. Next thing you'll be looking for is your what? 22nd what? 22nd term. Are we together? Yes, 22nd. Let's start taking it step by step, as I've said. Now, let's write it. So what did the question tell me? The question told me that the third term is what? 20. Are we together? And what? The eighth term is what? 35. Third term is 20, eighth term is 35. The question asks you to find A and all of this kind of stuff. So here, what is the formula of your third term? A plus what? 2D equals to what? 20, and this your 8 times what? A plus 7D equals to what? 35. Are we together? Then the easiest and the fastest way for me to get this is to what? Is to subtract both sides. I can call this one equation 1, and I can call this one what? Equation what? Equation 2. So from here I can say that equation 2 minus what? Equation 1. So what will I have? I will have A plus what? 7D equals to what? 35. And I have here to be A plus 2D equals to what? 20. Then on subtracting, what do I have? I find out that 7D minus 2D will give me what? 5D. And 35 minus 20 will give me what? 15. So from here I can say that my common difference is what? Is 3. So since my common difference is 3, then it is easier for me to put my common difference in anywhere, in any of the formulas that I want. I can say that put 7D equals to what? 35. You have A. You have 7. What's your difference here? 3 is equals to what? 35. And I have A equals to 35 minus what? Find the sum of three numbers. Or better still, the sum of three numbers in arithmetic progression. Sorry. The sum of three numbers in arithmetic progression is 15. The sum of three numbers in arithmetic progression is what? Is 15. Are we together? And the sum of their squares is 83. And the sum of their squares is 83. And the sum of their squares is what? 83. The question is what? Find the what? Find the numbers. Find the numbers. I hope you all got that question. And so from this question that I've said, so first thing I wanted to know is that the first number that you can just say that let the numbers be what? X, Y, and what? Z. Put that one there first. But one thing I wanted to do is that all of those numbers are in what? An arithmetic progression. I get what I'm trying to say like that. Are we getting it? And another thing I want you to know is that in arithmetic progression, not only can I move the term forward, I can also move the term what? Backwards. I get what I'm trying to say like that. That is, not only can I move the thumb what forwards, I can also have a scenario where I can move the thumb what backwards. That is, there's a possibility for existence of something as a minus 2d, a minus d, a plus d. I guess I'm trying to say like that. Know that your normal sequence and series computes number from where? From a, then up to your what? A plus d, then up to your what? Like that, like that, like that, like that, like that. But I'm telling you that there's a possibility that the number of your sequences or a time in sequences can move to the what? Can move to the back. So this question is an example of scenario like that. Since they say that the three numbers are in what? An arithmetic progression. So I can say that, since I said that numbers are x, y, and z, I can also say that x equals to what? A plus b, or x equals to a minus d, y is equals to a, and z is equals to what? A plus d. Are these the three numbers I want to use? Now question, why am I using these three numbers? Why am I not using any other kind of number? Probably a plus d, a plus 2d. Or why am I using why am I not using any kind of big number? The reason is that cancel out. I guess I'm trying to say like that. But if you are dealing with the normal terms in your arithmetic progressions, you'll be having something that is called what? An arithmetic linear and what? A quadratic equation. I get what I'm trying to say like that. So, and we are trying as much as possible to what? To avoid a lot of workings as you can avoid. I get what I'm saying. The thing is that if I use normal, okay, this is what will happen. Let's do it this way. I'll use this solution, use your normal term. Is that okay? So let's start. So the question said that the sum of these three numbers is what? Is 15. So that is a minus d plus a plus d must give you what? 15 minus, 15. Everything will give me 15. Then these two will cancel out. Then I have 3a is equals to what? 15. And a is equals to what? 5. So if a is equals to 5, note that. Now the next question has said that the sum of their squares is what? 85. That is a minus d squared plus what? A squared plus what? A plus d squared equals to what? 85. So from this my amount that I've paid, I can easily detect. For example, I can have 5 minus d, assuming I pay 5,000, plus 83, okay. Then so let's say I have 5 minus d squared here, plus what's my a here? 5 squared, plus what do I have here? 5 plus what? D all squared equals to what? 83. And so from here, if I open this bracket, what will I have? I'll have 25 minus what? Minus 10d plus what? Plus d squared. Are we together, please? Are we together, please? Are we sure? Where are we lost? What I was saying is that here, the term I want to use, I want to do it in a two way. The first time I want to use is I want to compute my answer in this way, and we'll compute it in the normal way. I'm just saying that assuming that all of these ones are still in AP, because if I want to find a common difference, what is the common difference of this one and this one? A minus D will give me what? Will still give me D. Yes or no now? And also A plus D minus A will still give me what? Will give me D. So all of these three that I've listed, they are still what? Are still in arithmetic what? Progression. But instead for me to move forward, I want to move what? Backward. So that I can have easy time to what? Cancel out. If I was to move forward here, none of my terms will cancel out. But we'll still talk about that. So let's do this one. The question says that the sum of their number is what? Is 15. So now this is one number. This is what? Another number. This is what? The third number. By the time you add up all of these numbers, what do I have? 15. And I hope you know that minus d and d will what? Will cancel out to give us what? 3a equals to 15. And here I can say that a is equals to what? 5. Yes or no? Since I've gotten a equals to 5. Now the next question now says that the sum of their squares is what? 83. That is, This one squared plus this one squared plus this one squared will give me what? 83. Yes or no? So that's what I'm trying to form now. And this one squared, this is what I had here, a minus d. But here, I know my a already to be what? 5. So substitute the answer here inside this place. And let's see what we have. So that's what I'm trying to do now. Are we all together on the same page now? Okay, good. So from here, if we expand this bracket here, what would I have? I will have 25, right? Minus 10d plus what? D squared plus what? 25 plus what would I have here? 25 plus what? 10d plus what? D squared equals to what? 83. Now I hope you know that minus 10d and plus 10d will what? We cancel out. How many 25 do I have in this case? 25 plus 25 is what? 50. 50 plus 25 is what? 75 plus what? This square do I have here? I have 1d squared, I have another square plus what? 2d squared, 83. Then from here, take this one to the other side. Then what do I have? 2d squared is equals to what? 83 minus 75. And I take that 2d squared here should give me, I don't know, 8. Then if I divide both sides by 2, d squared will give me what? 4. And d at the end of the day will give me what? 2. I get what I'm trying to say like that. So with this one, it is easy for me to get my what? Common difference and my what? And my thumb. So let's now go for the numbers. So let's now go for the numbers. So now, what is the first number? I have x is equals to what? A minus d. So what is my x here now? What is my a here? My a is what? 5 minus, what is my common difference here? 2. I can say that a is equals to what? 3. My y here is equals to a, and a is equals to what? 5. Now, my z is equals to what? A plus d, because my a here is what? I think 5 plus what? Common difference is what? 2, which is giving what? 7. That is, the numbers are what? 3, 5, and what? And 7. If you add them together, you have what? You have 15. And some of their squares will also give you what? 83. So now you see that it's easy for me to compute here. Now what will now happen if I now want to shift the term? Probably I say I choose a to be my first term, a plus d, and what? A plus 2d as the number of terms I have. Now adding this one together, what will I have? A plus d plus what? A plus what? 2d equals to what? 0. And dividing everything, I can have what? 3a plus what? 3d. I be now equals to 0. Then I can say that a plus d is equals to what? 0. Yes or no? Then from here I can answer that here a is equals to what? Minus d. I've not gotten a and I've not gotten d here. Then I will now have to go and add their sums again, which is what? A squared plus what? A plus d squared plus what? A plus what? 2d squared. At the end of the day, if you complete this one, you still have a what? A longer process than whatever I've just done on the board. Do you get what I'm trying to say like that? That's why, please, whenever you have sum of numbers that they ask you to find 3 consecutive numbers, it is best for you to shift those terms of the number what? Backwards. So that by the time you will be adding, you will have at least the common difference to what? To cancel out, at least. Do you understand what I'm trying to say like that? Do we get? Yeah, let's write it down. Are you ready? If you're ready, let me know. Ready? Yeah. Okay. We are ready. Let's know. Let's move. Are we done writing? Okay, good. So I hope we've gotten what we want to do here, like this. Let's get another question that is similar to this. Find three numbers in an arithmetic progression. That's another question. Now find three numbers in an arithmetic progression. 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 Are we together? Whose sum is 6 and product is minus 64. Whose sum is 6 and product is what? Minus 64. Are we together? Okay, as I've said, to make my work very easy. So what I will do here is that instead for me to use my normal term, so what will be my numbers now? My numbers will be what? A minus D, A, and what? A plus D. Now it will be very easy for me to compute. So by the time I add up all of this one here, what will I have here? So what is my A? I don't know, but I know that by the time I add them up, A minus D plus A plus what? A plus D will give me what? Will give me 6. Then this one will cancel out. Then I'll have what? 3A is equals to what? 6. And I can say that my A is equals to what? 2. Are we together? Now since my A is equals to 2, the question now says that the product of these three numbers is what? Minus 64. So that means A minus D multiplying A, multiplying what? A plus D equals to what? Minus 64. I don't know, but I know that A minus D and A plus D is difference of 2 squared, which is what? A squared minus D squared. And I was A equals to what? Minus 64. What is my A here? So I think I was 2 years old minus D squared open bracket 2 equals to what? Minus what? 64. Then from here, if I divide both sides by 2, what do I have? I have 4 minus D squared equals to what? Minus what? 32. Then if I swap them, I will find out that D squared is equals to what? 36. And D here is equals to what? 6. This is equals to 6. So if D will give me 6 here, so what would that happen? So what would happen now? Next thing that, so I can say that my numbers are what? A minus D, A, and probably A plus 2D. What is my own A minus D? My A here is what? 2 minus 6. My A here is 2. My A here is 2 plus 2 times 6 is what? Is 12. What is the number here? Minus 4, comma 2, comma what? 14. Do you understand? So if you add those three numbers together, okay, okay, sorry, We did not talk about and over two, okay. Some of the first 20 time of an iron, 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 Just quickly walk this on. Where's my G here? Where's my G? Where's my G? Where's my G? Where's my G? Where's my 2? Where's my 2? Where's my 2? Where's my 2? Where's my G? 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 Where's my one on an hour, 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 one on arithmetic progression, arithmetic progression, arithmetic progression, arithmetic progression, arithmetic progression, now arithmetic progression as first term 11, and arithmetic progression as first term 11 and fourth term 32, and fourth term 32, fourth, and fourth term 32, and fourth term 32. Find the sum of the first 9 terms. Find the sum of what? First 9 terms. So let's look at it again. Don't start now. What was I given? 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 What was I what? 32 minus 11 minus 11 minus 11 minus 11 minus 11 minus 11 5. 2 plus this is what? 9 plus 1 9 plus 1 9 plus 1 9 plus 1 9 Ma? 3 5 1 0. Okay, 3 5 1. 4.5 times 78. 3 5 1, Abby. That will be the final answer here. Alright, let's see example from a manual before we enter into geometric. The sum of the first term of an nth term, the sum of the first n term of an AP is 2n. The sum of the first n term of an AP is 2n. The sum of the first n terms of an AP is what? 2n. And the sum of the first 2n term of an AP is 3n. Oh, sorry, 5n. Let me come again. The sum of the first n term of an AP is 2n, and the sum of the first 2n term is what? 5n. Do you get that? Find the sum of the first 3n terms. Find the sum of the first what? 3n terms. Do we get that question? The sum of the first n term of an AP is 2n, and the sum of the first 2n terms is what? 5n. Question is what? Find the sum of the first 3n terms, right? Okay, good. Let's solve this. Okay, let's go. So the question said that Sn here is equals to what? According to the question, sum of the first n term is what? 2n. Okay. Next one again. That is S2n equals to what? And the question asks you to find what? S3n. Alright, so let's break Sn here. So Sn here. So if I work with Sn here, how is Sn here supposed to be? So I can say that Sn is equals to what? N over 2, open bracket, 2a plus what? N minus 1, minus 1, is 1, equals to what? 1, equals to what? 1, equals to what? Yes or no? 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 Let's keep this. Now, what is S2n? 2n equals to what? 2n over 2, open bracket, 2a plus 2n minus 1d. And everything is equals to what? 5n. Are we together, please? Are we together, please? Okay, good. So from here, I think this one here can cancel out this one here. So what? N open bracket 2a plus what? 2n minus 1d equals to what? 5n. Yes or no? Okay, so from here, so let's this one cross multiply by 2 here. What do I have here? I have n open bracket 2a plus what? N minus 1d equals to what? 4n. I'll get on and say like that. So I have this here and I have this here. But the question asks me, let me keep these two first. The question asks me now to find what? Sum of the first m. So that's sum of the first 3n. So that means S3n now should give me 3n over 2 bracket 2a plus what? 3n minus 1d. This is what I'm supposed to do. So, okay, let's hold this first. So from here, let's work with this. So what do I have? If I divide both sides by n, what do I have? I have 2a plus what? N minus 1d equals to 4. Yes or no? Then so from here, I can say that 2a is equals to what? 4 minus n minus 1d. Yes or no? Abi now? Okay, good. So let me substitute this 2a inside this place. So I can have 3n over 2 multiplied by, what do I have here? 4 minus, maybe this is n minus 1, Abi. That's 4 minus n plus 1d, or 4 minus, okay, n minus 1d plus 3n minus 1d. Then from here, we have 3n over 2. Please, are you getting what I'm doing, please? Are we sure? Okay, good. Then from here, what do I have? I have 4 minus dn. Are we together? 4 minus dn plus what? D plus what? What do I have here? 3n d minus what? Minus d. Yes or no? Yes or no now? Let's look at it. Let's look at the board together. 3n over 2 equals to 4 minus dn plus d. That is, if I use this one to open this bracket, this is what I will have. Are we together? Plus use this one to open bracket, this is what you will have. Can we continue now? Okay. So what do I have? I can have S3n is equals to, what do I have there, please? 3n over, what is that? Over 2 open brackets. What do I have? 4 minus dn plus d plus 3nd minus what? Minus d. So from here I can have 3n over 2 open bracket 4 minus this d and this d will what? We cancel out. Yes or no? What do I have here? 4 minus, what do I have here? 2nd. Yes or no? Okay, plus 2nd. Thank you. And I can have here to be 3n divided by 2 open brackets, or let me just remove 2 from here. Then what do I have here? 2 plus what? nd. Are we together? This one can cancel out. You can have S3n is equals to what? 3n open brackets 2 plus what? nd. Are we together? Okay, so think. So from here, let me get, so divide both sides here by n. I have what? 2a plus what? Sorry? 2a plus what is this going to give me? 2nd minus what? Minus d equals to what? 5. If I divide this side here by what? By n. You still get what I'm saying? Divide this one by minus, minus 2a minus d minus 5 over minus 2 now equals to what? nd. Yes or no? We Abi now? I don't understand at all. Raise up your hand. It's so that it's sorrow. What is the use of explaining to people that have been lost? I have Sn equals to what? 2n. I have S2n equals to what? 5n. So from here, in this format here, let's start. Sn equals to what? 2n. Then what is the formula of my Sn itself? Sn itself is what? N over 2 open bracket 2a plus what? N minus 1d, and everything is equals to what? 2n. Yes or no? Then from here, if I divide both sides by n, then what do I have here? What would I have here? If I divide both sides by n now, can you cause multiply here? What do you have? N open bracket 2a plus n minus 1d equals to what? 4n. Yes or no? Then n here will give me what? 2a plus what? N minus 1d equals to what? 4. Are we together? Then from here, use this d to open this bracket here. So what will I have here? 2a plus what? dn or nd minus d is equals to what? Equals to 4. Then from here, let me say that my dn here, if I remove dn in this case here, what will my dn give me? Then this 2 will go to the other side. I will have 4 minus 2a plus d. Let's keep this one. Do you understand into this part now? Okay, good. So continuing from this part, I hope you know that if, okay, now what will now be my S3n? S3n will now be 3n over 2 open bracket. What do I have here? 2a plus n, but this time it won't be n, it should be what? 3n minus 1d. Are we together? Then what would this one give us? That would be what? 3n over 2, open bracket what? 2a plus 3ng plus minus d. Yes or no? Then so from here, what can I have? I think I have gotten something in terms of what? dn here. So I can have 3n over 2 will give me 2a plus 3. What is my nd here? 4 minus 2 plus d. Are we together? I think this one here will not be minus d. Then I have what to be 3n over 2, open bracket. What do I have here? 2a plus 12 minus 6a plus 3d minus d. Then from here, 3n over 2. What do I have here? So let's start. I have 12. What's the next thing that I have here? Minus 4a plus 2d. Then if I reduce everything by what? But if I reduce everything by 2, what will I have? I'll have what? 3n, open bracket, 6 minus 2a plus what? Plus d. Hold this answer, please. Can we write that, please? Sorry. I will take it up. I will take it up, please. I will take it up, please. Okay. So look as if we misinterpreted the question. I'm sorry about that. 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 Here, 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 two nd minus d equals to what? 5. Then from here I can have 2nd equals to what? 5 plus what? D. Are we together? Are we now? Okay, let's leave it like this first. Now, in the first one that we did here, let's come back to this place here. So I think that one we had, what did we have there? We had 2a plus what? dn, are we together? Minus d equals to what? 4. Do you get what I'm doing, please? And so from here, let's subtract both sides. Then if I subtract both sides, what do I have here? I have everything here to be what? 0. 2nd and dn is the same thing, which will give me what? nd. Everything will give me what? 0. And this one, I'll say that my n here is equals to what? 1 over what? 1 over d. Are we together? So this if I have my n equals to 1 over d, then what? My s3n will now be what? 3n over what? 2, open bracket, what over what? 1 over n. From here I can now have 3n over 2. And don't forget that my d is equals to what? 1 over n. And what can I have here? I can have 3n over 2, open bracket, 2a plus 3n. What is my d? 1 over n. Are we together? Minus d, which is what? N. Then so from here, this n can cancel this n. And I'm left with what? 3n over 2, open bracket, 2a plus what? 3 minus 1 over what? Happy now? Are we together? 2a plus dn minus d equals to 4. 2a plus my d is 1 over n multiplied by n minus 1 over n equals to what? 4. This one can cancel each other. I can have 2a minus 1 over n equals to what? 4. Then taking this one to the other side, so I have 2a is equals to what? 4 plus 1 over n. And if I take the LCM here, over 1, so I can have 2a is equals to what? 4n plus 1 over what? N here. Are we together? Are we together, please? Yes. Then so from here, what do I have here? I have a to be what? 4n plus 1 over what? Over 2n. Yes or no? Yes or no? I have gotten this a here, so let me substitute this value of a inside this place. They can have 2. What is my a now? 4n plus 1 over what? 2n plus what? 3 minus 1 over n. Then 2 can cancel this 2 here. And I'm left with what? 3n over 2, open bracket, 4n plus 1 over n plus what? 3 minus 1 over what? N. So if I take LCM of everything here, I would have 3n over 2, 4n plus 1 plus 3n minus 1 over what? Over n. Are we together, please? Then this one can cancel out. Then what do I have here? I would have 3n over 2 multiplied